Hey guys, tonight we're drifting somewhere both impossibly close and impossibly far to that silver coin in the sky. You've stared at 1,000 times without ever really seeing it. The moon, a place we've always been told is utterly dead. No air, no rain, no wind, no sound, just a silent frozen stone hanging in space. And yet a few strange clues keep whispering that maybe the moon isn't quite as lifeless as we think. That beneath its stillness, it might still have something resembling weather. Not weather like our clouds and storms, but something quieter, stranger and hauntingly slow. You probably won't survive this. Of course, the vacuum alone would turn your blood into a champagne fountain in seconds. But hey, that's why you're doing this from bed instead of a lunar crater. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're awake enough, drop your location and local time in the comments. I love seeing where all of you are drifting off from. It makes this lonely moon feel a little less empty. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You float above the pale surface, the horizon bending sharply under a black sky that never brightens, never fades. There's no wind here, or so they say. No air to carry the sigh of dust or the whisper of a shifting grain. But still something stirs. It's faint, hidden in the static hum of sunlight and the long shadow of night. Through Eye Atlas. That quiet observatory orbiting far beyond the Earth has been watching, measuring and wondering. Its instruments pick up rhythms too subtle for eyes, faint pulses, microcharges, little tremors in the lunar soil that suggest the moon is breathing if only a little. You can almost feel it under your imaginary boots, a kind of tension between day and night. On the sunlit side, temperatures rise past boiling. On the dark side, everything freezes harder than dry ice. That brutal contrast creates expansion and contraction pressure and release like the world's slowest heartbeat. Scientists call it thermal cycling. Poets might call it lunar weather. If you crouch closer, careful not to imagine the crunch of regolith, because remember, sound doesn't travel here. You'd see dust flicker in slow motion. Each particle charged by sunlight dances upward before settling again like a sigh. It's not a storm, it's more like static snow. Apollo astronauts saw it, two strange glows and hazes near the horizon, as if the moon were exhaling light. Still, most scientists used to shrug. It's just dust, they'd say. Just electrostatic nonsense. But 3-Eye Atlas doesn't shrug easily. It keeps asking what moves the dust, what makes it rise, and why it glows even when the sun is hidden. And that's where the mystery begins, because the data hints that something keeps stirring, long after sunlight fades, long after energy should vanish. The moon's so-called stillness, it turns out, is an illusion of distance. Up close, everything moves, just not the way we expect. The surface creeps. The regolith shifts like powder on a slow tide. Even the tiniest impacts from micrometeorites throw up invisible clouds that drift in patterns, forming something that behaves almost but not quite like weather. Scientists still argue whether to call it that. Atmospheric phenomena without an atmosphere sounds contradictory, but so does everything about the moon. When you look at it now, you can almost sense its subtle motion, the way light moves across craters, the shimmer at the edges where cold meets heat. It's not still, it's patient. Each phase, each shadow, each glint of frost is part of a long, quiet cycle. Down in the data vaults of 3-Eye Atlas, those rhythms are charted like a heartbeat monitor for stone. Tiny temperature rises, sudden blips in magnetic charge, faint movements of sodium in the exosphere. The graphs look alive, not in the biological sense, but in the way landscapes pulse with energy. You imagine yourself there, sitting at a console surrounded by screens whispering with telemetry. Outside space is infinite and silent, but inside the machines are listening to dust. One technician jokes that the moon's just gossiping, releasing secrets, one static crackle at a time. Another swears they've seen patterns that look like weather maps, miniature systems of drift and fall, rising and fading like winds on Earth. There's a sense of reverence in the lab, the same kind you feel standing by an old tree or looking into deep water. The moon has been our mirror for millions of years, guiding tides, calendars, myths, and now we're realizing it might be more active than we dreamed. And that thought, that something can look perfectly still yet be quietly alive, settles into you as you breathe slower, feeling the hum of your own blood echoing the pulse under the dust. You realize that maybe weather doesn't have to roar or flash. Sometimes it just hums at the edge of hearing a whisper beneath the static of time. The moon's skin is older than memory, a face tattooed by impacts that froze into permanence. You glide now over its scarred plains, feeling each crater like a punctuation mark in a story that began before Earth's seas even learned to shimmer. The scientists at 3i Atlas call it a record written in shockwaves. Every pit, every ridge, every faint ripple of ejecta is an entry in a weather journal, just not the kind filled with clouds and storms. Instead, it's one of collisions, heat, and violent transients. When a meteor strikes, it doesn't just dig a hole. It releases light plasma and vaporized rock that spreads outward like a brief airless hurricane. For a moment, the moon has an atmosphere thin as breath and gone just as fast. You can picture it dust arcing up, rolling like smoke in slow motion, then settling again. Scientists still argue whether those fleeting clouds of gas could ever have lasted long enough to change the landscape, a kind of prehistoric lunar weather that sculpted craters the way rain sculpts riverbeds. You imagine one such impact long ago. The sun hides beyond the horizon, the surface frozen solid. Then suddenly the sky ignites, if you can call it a sky. A rock no larger than a house slams into the regolith, and in a heartbeat the silence becomes light. The blast hurls vaporized minerals into space, forming a glowing bubble that expands, cools, and collapses. Within seconds it's over, but traces remain, faint chemical ghosts still detected by orbiters today. 3i Atlas can see their signatures: sodium, potassium, argon, helium. The same elements we breathe, only here they rise and vanish in minutes. You drift lower, feeling the afterimage of that long-gone storm. The ground here is glassy, formed when the rock melted and refroze. When sunlight hits at the right angle, the melted plains glitter like frost. It's easy to see why early astronomers thought the moon had seas. They named them Maria, the Sea of Tranquility, the Sea of Serenity, but what they were really seeing were the scars of ancient fire. A mainstream fact, and one they rarely tell in school, many of those lunar seas were born not just from impacts, but from floods of molten basalt that poured across the surface billions of years ago. For centuries people thought they were calm plains. In reality they were lava oceans hot enough to make stone boil. The moon quiet now once raged like a planet with a temper. There's a fringe theory, of course, there always is, that some of that volcanic activity lasted much longer than scientists admit. A few researchers think faint plumes might still vent gas from the deep interior, explaining recent detections of radon. It's an idea that keeps 3 Atlas's data team up late, sipping reheated coffee and arguing in whispers. If there's gas, one says there's pressure. If there's pressure, there's weather. You smile because it's a stretch, but a poetic one. After all, what is weather except change over time? Maybe the moon's storms are just geological sighs stretched across millennia. You glance down again and notice how every crater seems to overlap. Another, the marks of endless renewal through destruction. In one small basin, something catches your attention, a glint almost like moisture. Of course it's not water, but the regolith there is unusually smooth, its grains welded together. This is the site of an ancient impact melt where heat and vapor once rolled like a pyroclastic wave. In a strange way, it resembles the cooled ash of a volcano back on Earth, as if the moon had its own seasons of fury. It's funny how people talk about the moon being static. Even now, new craters appear every year. NASA's Lunar Reconnaissance Orbiter has photographed fresh scars forming between missions. Some are only a few meters wide, but each one unleashes a burst of dust that briefly creates a shimmering veil, a local weather event that lasts perhaps half an hour then fades into the void. 3i Atlas detects these flares as tiny upticks in reflectivity, like lightning that refuses to flash. You float onward, passing over the enormous Tycho crater, the youngest of the great scars. Its rays stretch like a spider's web for more than 500 kilometers. From this height they look like frozen rivers of moonlight, but they were once ejecta plumes, rock thrown so far that it wrapped the moon in a veil of particulate haze. For days afterward the whole surface would have glowed faintly from charged dust, a world briefly alive with motion. Scientists still debate how long that haze might have lasted. Some think it dissipated within hours. Others argue that electrostatic forces could have kept particles suspended for weeks. Either way, it's evidence that the moon once had weather windows, fleeting intervals where its sky wasn't empty, but glittering, turbulent, alive. Down below, you imagine standing on the edge of that crater right after impact. The ground still warm, the horizon wavy with dust, the air non-existent, yet full of movement. You can't breathe here, but somehow the scene feels more alive than any desert on Earth. Maybe it's the contrast, the way the black sky amplifies every glint, every shimmer, every whisper of light. There's a strange peace in that thought. Even destruction here feels slow, deliberate, patient. The moon doesn't rage, it endures. Its storms are memories now frozen in glass and dust, preserved for anyone patient enough to listen. As you drift higher, the view flattens into geometry circles within circles, patterns of violence long forgotten. Somewhere inside that pattern a pulse remains faint, mathematical, persistent. 3i Atlas calls it the echo signature. You half asleep call it breathing. You're still gliding over that silent landscape when a thin shimmer catches your eye, a veil of particles too faint to be seen from Earth. The instruments aboard 3 Atlas call it an exospheric wisp, though that phrase is about as romantic as calling sunlight photon leakage. You can imagine the data scientists arguing over coffee again, trying to find the right metaphor. One of them jokes that the moon's atmosphere is so thin it makes your ex's excuses look substantial. They're not wrong. Technically, the moon does have an atmosphere, if you can call it that. It's so tenuous that all the gas molecules on the surface, if gathered together, could fit inside a single truck. But those ghost atoms, helium, neon, hydrogen, even traces of sodium and potassium do something curious. They move. They migrate from the sunlit side to the dark, carried not by wind but by the whisper of thermal energy. In their lazy dance, they form what some researchers have started calling ghost air. You imagine standing there, helmet visor down, as morning sunlight creeps over a crater rim. The surface begins to warm, and suddenly atoms start to drift upward, not enough to rustle a flag or carry a scent, but enough to register as motion. If you could somehow shrink yourself to the scale of a molecule, you'd feel it a faint tide rolling over an infinite desert. Scientists still argue whether this should count as weather. Some say it's just chemistry, a form of surface sputtering. Others point out that these particles flow shift and respond to cycles of light and shadow, essentially doing what winds do, just in ultra-slow motion. 3i Atlas seems to side with the romantics. Its telemetry reveals daily tides of atoms swelling and receding like breath. The mainstream fact goes like this: the moon's exosphere was first detected in the 1960s, when astronomers noticed strange emissions of sodium and potassium glowing faintly around the lunar disk. Later telescopes confirmed that this invisible bubble stretches thousands of kilometers into space, thin but persistent. Its source likely a mix of solar wind micrometeorite impacts and the natural decay of radioactive elements in lunar rock. But the quirky detail, the one that makes scientists raise an eyebrow, is the sodium tail. Yes, the moon has a tail like a comet. It extends away from Earth, sometimes millions of kilometers long, shimmering faintly in yellow light. You can't see it with your eyes, but spectrometers can. Every time the new moon passes between us and the sun, that tail sweeps across our atmosphere, painting the sky with atoms that no one notices. It's the kind of cosmic trivia you'd mention at a party and immediately regret when people start asking if you're okay. Up here you watch those atoms drift like invisible confetti. The 3i Atlas sensors trace their flow, showing how solar radiation nudges them eastward, how micrometeoroid strikes puff them upward, how electric fields make them dance. It's like watching smoke signals written by a world that forgot language but still remembers rhythm. Somewhere in the control room back on Earth, a young researcher notices a pattern, tiny pulses always around lunar dawn. It's as if the moon takes a deep breath when sunlight touches its rim. They've seen it 3 months in a row now, regular enough to make people whisper about lunar weather fronts. A veteran scientist frowns at the term. It's not weather, she says. It's physics. Then she pauses. But maybe that's all weather ever is. You smile at that. Because really, what's the difference between an atmosphere and an attitude? The moon has both thin, invisible, and occasionally unpredictable. You drift lower again, tracing the ghost air. The sodium atoms are restless tonight, gliding just above the surface like glowing pollen. A micrometeorite zips past and slams into the regolith, vaporizing on contact. For a split second, you see a puff of light, a spark that adds a few hundred more atoms to the exosphere. The moon doesn't roar, it exhales. For decades, scientists dismissed the idea of lunar weather because they were expecting clouds, rainstorms, something visible and loud. But now, instruments like those on 3 Atlas have begun to detect patterns that defy the old definitions. There are pressure gradients, however tiny. There are currents, however brief. There's even day-night circulation if you measure precisely enough. You could almost laugh. Earth spent centuries dreaming of the moon as a static and motionless thing, and now we're finding out it blushes and breathes. The debate grows stranger the deeper you go. Some fringe researchers have proposed that this exosphere interacts with the lunar soil in complex ways, triggering faint dust geysers that mimic microstorms. Others think the moon's crust acts like a capacitor, storing electrical energy and releasing it in bursts that move matter around. 3i Atlas has recorded flashes that might support this tiny silent flickers along the Terminator line too regular to be coincidence. There's an odd comfort in it. Even here, in a place colder than logic, nature still insists on motion. The moon refuses stillness the way a sleeping body still breathes. You look down one last time at that silver haze and realize something humbling. Even the emptiest places have rhythm. Every silence hides a pulse. Every void hums with small persistence. Maybe that's the real secret of lunar weather. It's not about wind or rain, but about endurance. The kind of slow change that takes patience to notice. You drift through the dark side's edge just as the sun peeks over a jagged ridge. The light crawls, not bursts. It doesn't flood the surface like it does on Earth. It creeps grain by grain as if it's afraid to wake the dust. You remember what the Apollo astronauts reported during those first missions, the so-called horizon glow. They swore that before sunrise, when everything should have been pitch black, they saw a faint silver shimmer stretching across the horizon, almost like mist caught in twilight. At first, Mission Control thought it was just instrument glare, maybe sunlight scattering inside the capsule windows. But the reports kept coming. It looked like dust suspended above the surface, one astronaut said, as if the moon was glowing. Nobody had words for it. Then glowing dust in a vacuum doesn't exactly make sense. Yet there it was, recorded by cameras, confirmed by later probes, and still defying easy explanation half a century later. Scientists still argue whether this horizon glow was light reflected by floating dust or some strange electrostatic phenomenon. 3i Atlas, ever the insomniac observer, has been gathering evidence for both. The patterns it's detected, arcs of faint brightness that pulse just before sunrise, suggest a kind of atmospheric shimmer, the moon's version of dawn fog. Except there's no air, no moisture, no sky. Just dust and sunlight performing an optical trick together. You hover above one of those glowing rims now watching. The ground is still frozen in shadow, a kind of black velvet nothingness. Then the first light touches it, and the dust begins to rise. Not in plumes or gusts, but in little quivers, particles hopping, hovering, then falling again. It's as if each grain feels the sunlight as an electric itch. The moon, against all odds, looks alive. Imagine standing there during that brief shimmer, your boots planted in fine powder, the horizon just beginning to glow. You'd swear a storm was coming, the air charged your suit humming with static, but there's no wind, there's no sound, only movement too small to hear. One of the strangest things 3i Atlas discovered is that the glow doesn't stop when the sun fully rises. It moves, following the light as if the moon's surface is breathing. Even more mysterious, the same glow appears again at sunset, flickering in the opposite direction. Some researchers think it's the work of charged dust leaping between light and dark regions. Others think it's a mirage caused by solar wind particles colliding with the regolith. Either way, it's weather without air, a luminous dance of dust under the solar tide. You think about those Apollo suits, thick white and covered in fine grey powder after every walk. The astronauts complained that the dust clung to everything, stuck to fabric-scratched visors, smelled faintly of gunpowder. It was electrostatic, magnetized by sunlight and friction. It got everywhere, one of them said, and it wouldn't come off. They joked that the moon had a vendetta against cleanliness. But maybe that clingy dust was part of the same system, a global circuit that shifts with every sunrise and sunset. 3i Atlas detected repeating cycles, dust density rising at dawn, dropping by noon, then spiking again when darkness returns. It's subtle, almost poetic, as if the moon marks time not with clouds or storms, but with waves of static. There's a mainstream explanation, of course, the so-called photoelectric effect. When sunlight hits the lunar surface, it knocks electrons loose, leaving the ground positively charged. In shadowed regions, electrons pile up, making them negatively charged. The result, a voltage difference strong enough to make dust particles repel one another. They rise, drift, and fall like pollen caught in invisible currents. Now imagine the whole moon as one giant circuit board. Day and night shift like alternating charges driving dust from one side to the other. That faint glow the astronauts saw. It might have been the visible trace of those movements, a natural light show powered by the sun. Still, there are stranger ideas. A few fringe theorists suggest the glow might come from tiny ice crystals sublimating, melting directly from solid to vapor in the heat. But that would mean there's water mixed in with the dust, and that opens a whole new argument. Scientists still debate how much water, if any, hides beneath the regolith. Every new discovery hydroxyl traces here frozen molecules. There adds another whisper to the mystery. You smile because that's what makes the moon so irresistible it keeps pretending to be simple only to surprise us with secrets. Even in silence it has moods. Even in darkness it glows. Imagine that from your window on Earth, the moon rising full and pale, a steady coin of light. You think it's the same face every night, but up close it's restless, shimmering alive with invisible storms. The glow is its confession, its way of saying, I may look calm, but I'm never still. Somewhere inside 3 Atlas, the data keeps scrolling quiet and precise, translating that shimmer into lines of code and graphs. But you know what those scientists won't say aloud, that what they're really studying isn't dust or light, but a feeling, the first hint that even the loneliest world still dreams of motion. If the horizon glow is the moon's first whisper, then what comes next is its quiet heartbeat, the static that makes dust dance. You drift lower into the light again, where the boundary between day and night slides across the regolith like a living thing. Here the sunlight isn't gentle, it's electric. Every grain of dust, every shard of glassy basalt reacts to the storm of charged particles streaming from the sun. They don't just warm up, they charge up. When sunlight hits the surface, it kicks electrons free, and those freed electrons don't like to sit still. They leap, crawl, and occasionally soar, creating pockets of differing electrical charge. Some regions become positive, some negative, and between them forms a microscopic tug-of-war. You wouldn't feel it through a glove, but if you could shrink yourself down to the scale of the dust, you'd be surrounded by an invisible tempest, the tiniest thunderstorm in the solar system. The scientists at 3i Atlas like to call this the lunar fountain. It's not poetic, it's literal. Dust grains, sometimes only a few microns wide, are repelled by the charged surface until they leap upward, hang for a few seconds, and then drift back down. It's not a gale, not even a breeze, but it moves matter. From the data's point of view, it's weather. The Apollo astronauts may have caught a glimpse of it too. When they stepped outside their landers, they saw halos of light glimmering around their boots. Later they found the dust didn't just stick, it jumped. It floated in slow arcs, moved in patterns that didn't match their movements. It's alive, one astronaut muttered into his mic, half joking, half uneasy. Scientists still argue whether those arcs were just a quirk of static buildup or the visible signature of a larger lunar process. 3i Atlas, with its laser altimeters and dust detectors, keeps seeing it happen. Brief surges in reflectivity, slight rises in local charge, faint upward drifts of particulate matter. All synchronized with the passing of the Terminator, that moving line between light and dark. You watch it unfold now, hovering over a ridge where sunlight is advancing. The shadow retreats like an ocean wave. As it does, the dust there begins to shimmer, rising a few centimeters into the airless void. The movement is hypnotic, like watching sand vibrate to an unseen frequency. Some fringe researchers have gone further, calling it electrostatic weather. They imagine the moon as an enormous capacitor constantly charged and discharged by solar radiation and Earth's magneto-tail. To them, every dust hop, every grain's ascent and fall is a kind of lightning storm in miniature. The only difference is that here the flash is silent. You picture that in your head, lightning, without thunder rain, without water clouds made of powdered glass. It's almost absurd, but then again, so is every miracle of physics. The line between science and poetry gets thinner the longer you stay awake. A mainstream fact, the lunar surface can build up potential differences of hundreds of volts between sunlit and shadowed areas. That means if you placed a metal rod across the line of sunlight, you could in theory draw a faint current, the world's slowest solar battery. It's not enough to power your phone, but it's proof that the moon is alive with electricity. Now here's the quirky part, that electricity might move dust across entire planes. Simulations show that fine particles could surf the moon's electric fields, gliding kilometers at a time. Think of it, a dust grain leaving one crater at dawn, traveling silently over the horizon, and settling again at dusk. It's motion, without air flight, without wings. 3i Atlas instruments have even recorded these journeys indirectly by tracking the way light scatters differently after each lunar sunrise. The pattern isn't random, it repeats like tides. That's why some of the team started jokingly naming them after Earth's winds: the regolith drift, the tranquility stream, the Tycho gust. You imagine the whiteboard in the control room full of arrows and sketches of weather systems, on a world that technically has no weather. One night, a junior researcher asks during briefing if the dust moves and the light changes in the electric field cycle, isn't that a kind of atmosphere? The room goes quiet for a moment. Then someone says it's more like a memory of one. That line sticks with you. Because really that's what this is, not true weather, but a ghost of it. The moon remembers what it was like to have air long ago when volcanoes vented gases and impacts made temporary skies. Now it repeats that rhythm in miniature, a mimicry of breathing played out in charged dust. As you watch, another wave of light sweeps over a crater rim, and you can see particles still drifting upward, as if reluctant to settle. You think of snowflakes in sunlight, the way they hang weightless for a second before melting. You could almost imagine a breeze if you didn't know better. And in that imagined breeze you hear the quiet heartbeat of the moon, an electrical rhythm that hums beneath the silence. Every time sunlight strikes the dust, every time shadow cools it again, the cycle repeats. It's weather at the edge of definition motion, at the threshold of stillness. You breathe out, slowly matching its rhythm. The fan in your room hums like distant solar wind. The air feels thick but gentle, alive but calm. And for a moment you and the moon are the same two bodies, quietly charged, dreaming of movement in the dark. Now that you've watched the dust rise and fall, it's time to feel the deeper rhythm beneath it, the great lunar pendulum of heat and cold. The moon doesn't do moderation. There's no gentle spring, no cozy autumn, no humidity to soften the swing. It's pure contrast, a daily cycle so extreme it would snap steel and turn air to glass. You're about to experience temperature whiplash. Imagine this: at lunar noon, the surface bakes at about 127 degrees gas, hot enough to boil water, melt solder, and make your lunchbox sizzle like a skillet. But a few hours later, as the sun slips beyond the horizon, that same soil plummets to 173 degrees. The heat escapes instantly because there's no atmosphere to trap it. It's like switching from a blast furnace to a cryogenic freezer in a single rotation. You hover just above the Terminator line again, where day meets night. It looks peaceful from orbit, a soft curve of silver, but beneath that glow lies a brutal frontier. On one side, dust expands and crackles with solar energy. On the other, it contracts and stiffens into stone. The regolith pops microscopically, the grains separating, clicking like tiny knuckles. This is the moon's version of weather. Not wind, not rain, but expansion and contraction. Over billions of years, that silent breathing has shaped the landscape. Rocks fracture, cliffs crumble, pebbles shift downslope in slow-motion avalanches. NASA calls it thermal fatigue. You might call it the world's slowest earthquake, or maybe the gentlest kind of storm. A mainstream fact: the Apollo seismometers left behind by the astronauts detected daily microquakes linked directly to this heating and cooling. Every sunrise, a faint tremor. Every sunset, another. The moon literally creaks with temperature. You can almost imagine it sighing, exhaling light and dust as it turns. 3i Atlas tracks those thermal pulses from orbit. Its infrared sensors paint the lunar surface in color maps: red where the light strikes, blue where the cold reigns. From above, the planet looks alive, pulsing with infrared veins. If you speed up the data, compress one lunar day into a few seconds, it looks like breathing the whole body of the moon, inhaling light and exhaling shadow. That image caught the attention of an artist on the team who called it the heartbeat of stone. It went viral for about 5 minutes before people moved on to cat videos, but the scientists kept the phrase. Now, whenever they brief each other on new data, someone will murmur, "Any change in the heartbeat?" There's something strangely comforting about that. Even a dead world keeps its rhythm. But here's the quirky part: those temperature swings don't just crack rocks, they might create vapor. In 2021, researchers detected faint hydrogen and hydroxyl signals near crater rims that appear and vanish with the lunar day. The theory: some trace molecules of water or ice sublimating at dawn, recondensing at night. In other words, a frost cycle, the gentlest possible weather system. 3i Atlas instruments have picked up similar traces, though the readings are almost too small to trust. Still, it's enough to make people whisper about lunar dew. Scientists still argue whether it's real. Some say the signals come from the instruments themselves or from solar wind contamination. Others swear the data is consistent. If there's dew, one researcher said, then the moon has mornings. You imagine that mornings on a world without air. Frost glittering under black sky, evaporating into silence. No birds, no breeze, just sunlight turning crystals to vapor. Maybe that's why astronauts said the dust sparkled like diamond powder. Maybe it really was. You float lower again, passing over a ridge half in shadow. The temperature gradient is so steep you could almost see it. The sunlight side glows faintly red in infrared. The dark side is colder than Pluto. If you had a thermometer, it would shatter from the contrast. And right along that razor-thin line, molecules flee, darting from hot to cold, an invisible migration like air current slowed to a crawl. The 3i Atlas team jokes that if you ever tried to camp here, you'd need one boot in a freezer and the other in an oven. But even that absurdity has meaning. It's the boundary between life and nothing, the same kind of edge Earth's early ecosystems once clung to. Heat meets cold, energy meets stillness, and somehow out of that tension movement happens. On some nights when the moon's orbit brings it through Earth's magnetotail, those temperature cycles change slightly. Solar particles drop, magnetic flux increases, and suddenly the thermal map wobbles. The scientists call it lunar weather interference. You call it Earth's ghost wind, our planet reaching out to touch its oldest companion. Every environment has its own kind of storm. On Earth it's thunderclouds and hurricanes. On Jupiter it's ammonia whirlwinds the size of continents. On the Moon, it's this an endless alternation between blistering day and frozen night, a silent, predictable violence. And yet standing here in your imagination you find it peaceful. The silence becomes a kind of lullaby. You watch light crawl, watch shadow advance, and feel yourself slow to their pace. No rush, no deadlines, just heat leaving stone, then returning. If you listen closely, you can almost hear it, the faint pop of cooling rock, the static whisper of charged dust, the hum of temperature moving through soil. The Moon doesn't need air to sing, it just needs time. The whiplash of temperature is brutal, yes, but it's also balance, the kind of balance that keeps the system alive in its own alien way. And as you breathe, you realize your lungs are just doing the same thing, taking in warmth, letting out cold, adjusting to the cycle. You and the Moon share more than you thought, a rhythm of heat, a pulse of light, and the quiet, stubborn persistence to keep turning. You drift now toward the Moon's darker basins, where sunlight never reaches the permanent shadows of the polar craters. They're colder than the vacuum of space, blacker than any ink, and yet they hold one of the Moon's most tantalizing secrets, frozen gas. Here, at the edge of nothing, the Moon hides its breath. You descend slowly over a crater called Shackleton, its rim gleaming faintly while its interior is absolute void. The temperature here never rises above 230 degrees. That's cold enough to freeze even helium to trap atoms that would otherwise escape into space. Scientists call these places cold traps, and they might be the closest thing the Moon has to a lung. The 3i Atlas sensors have been listening to them for years. Occasionally they pick up faint bursts of gas argon hydrogen, maybe even carbon monoxide escaping in tiny puffs. Too brief to see, too small to form clouds, but enough to register as motion. The Moon exhales through these shadows, and though it takes months between breaths, the rhythm is unmistakable. Imagine standing there right at the boundary between light and cold. Your visor fogs instantly, the ground beneath you glittering like powdered glass. The sun's warmth ends at your boots, while just ahead lies an abyss that could swallow sound. If you waved your arm, ice dust might drift up like fog, only to freeze mid-air. It's a world of contradictions, no air, yet a kind of weather all its own. A mainstream fact when the L-Cross mission slammed a spent rocket stage into one of these polar craters in 2009, it threw up a plume that revealed water ice, methane, and even traces of organic compounds. The discovery was revolutionary proof that the Moon isn't entirely desiccated. But the weird part came later, when follow-up missions found evidence that the ice shifts slightly over time. Not much millimeters, maybe centimeters, but enough to suggest sublimation. In other words, some of that frost is evaporating into space only to refreeze elsewhere. That means circulation. That means movement. That means weather. Scientists still argue whether those tiny plumes could be caused by micrometeorite impacts or internal gas release. But 3i Atlas detected a curious pattern. The outgassing seems to increase during the full moon, when solar radiation peaks. One engineer called it the lunar tide turned inside out. Instead of oceans responding to gravity here, frozen gases respond to light. You watch it happen from above. As sunlight grazes the crater rim, a mist of sodium and argon rises invisibly, refracting just enough to register as a shimmer on your screen. The particles drift upward, then vanish into the exosphere. Some of them escape entirely, forming the Moon's faint sodium tail, the that stretches behind it like a comet. Others fall back, condensing on the dark side as a fresh layer of frost. It's so quiet you can almost hear it, that slow, vaporous heartbeat. If you sped it up 1,000,000 times, it might look like breath fogging a mirror. The moon breathing through its shadows. There's a fringe idea floating around that the cold traps might not just store gases but generate them. A few researchers speculate that cosmic radiation and solar wind striking buried ice could spark chemical reactions, hydrogen, combining with carbon to form simple organic molecules. Over eons, these molecules might accumulate, forming a kind of frozen chemistry lab. It's the kind of claim that gets dismissed in academic meetings and quietly revisited after midnight. 3i Atlas's instruments haven't proven it, but they've caught spikes in mass spectrometer readings that make people squint. Either we hit a cosmic ray burst, one scientist said, or something down there just burped. You drift lower still, the light fading to nothing. Down here there's no horizon, only texture. Ice and rock blend into each other, and the ground feels porous, fragile. You imagine brushing your hand across it and leaving a trail of glitter that never melts. These polar shadows are a paradox. They never see the sun yet, they are sculpted by it. Over millennia, sublimation and refreezing have created delicate ridges like frost dunes. Some even think there could be microfissures where gases migrate below the surface, the moon's version of underground currents. The temperature differences between illuminated rims and frozen interiors might drive pressure changes that push gas through pores in the regolith. It's not a breeze, it's not even a hiss. Its motion so faint that only instruments like 3i Atlas can catch it. You pause at the edge of one such ridge. The frost here is pure untouched since perhaps the late heavy bombardment, when asteroids pounded the solar system and left behind the ingredients of water. You realize you're looking at time itself frozen mid-breath. Each molecule of ice is a relic of collision, a survivor of chaos now resting in absolute stillness. And yet even here the surface changes. Micrometeorites strike constantly, tiny pinpricks of heat, melting ice into vapor that drifts upward before freezing again. The process repeats endlessly, reshaping the frost, refreshing it. That's the moon's weather, eternal repetition at glacial pace. If you zoom out now, the crater looks alive, bright edges dark heart, thin blue-grey haze at its boundary. From orbit, 3i Atlas watches these interactions like a doctor tracking slow respiration. Some nights the sensors pick up faint magnetic anomalies, too little pulses matching the timing of gas release. It's coupled, a researcher murmurs one evening. The gas moves, the field twitches. You think of your own body, the way breath changes heartbeat, the way warmth meets pulse. You start to realize that the moon, in its frozen stillness, does something similar. It inhales radiation, exhales gas. It contracts and expands. It even flickers electromagnetically with every solar gust. And suddenly you no longer see it as dead. You see it as old, unimaginably old, but still working, still reacting, still breathing in its own alien rhythm. So the next time you look up and see that pale half-disk above the horizon, remember what 3i Atlas knows. Even the darkest crater has weather. It just happens too slowly for our impatient eyes to see. You rise from the shadowed pole and drift back into light. But this time you notice something new. The moon doesn't orbit in perfect isolation. Every 29 days, as it loops behind Earth, it enters the long, invisible tail of our planet's magnetic field, a ghost river of charged particles stretching millions of kilometers into space. The scientists at 3i Atlas call it the magneto-tail, but you could think of it as Earth's touch. For about 5 days each month, that touch changes everything about the moon's delicate electrical weather. Imagine you're there hovering near the terminator line, watching the blue shimmer of Earth rising above the horizon. The usual solar wind has quieted. You've entered Earth's shadow. Now, instead of being bombarded by the sun's plasma, the moon is bathed in particles leaking from our own atmosphere, oxygen, hydrogen, and traces of nitrogen, all trapped in that magnetic wake. It's as if Earth exhales and the moon briefly breathes in. And mainstream fact satellites have measured this exchange for years. When the moon passes through the magneto-tail, oxygen ions from Earth's upper atmosphere hitch a ride along magnetic field lines and land on the lunar surface. Scientists confirmed it. Using isotopic fingerprints, the oxygen in lunar soil matches Earth's. In a poetic twist, the air you're breathing right now has distant cousins embedded in moon dust. But 3i Atlas noticed something stranger. Each time the moon enters the magnetotail, the electrostatic dust fountains, those tiny leaps of charged particles, behave differently. The rhythm changes. The currents slow, then pulse almost as if responding to Earth's heartbeat instead of the sun's. One researcher described it as magnetic weather. Another called it the Earth's shadow wind. You prefer the second term, it sounds less like math and more like mythology. You picture it happening now. The lunar surface, usually bombarded by solar radiation, suddenly relaxes in the dark calm of Earth's magnetic umbrella. The temperature steadies, the dust settles. Then as charged particles begin to flow in from Earth, faint electric discharges spark across the surface, unseen but measurable. It's the quietest thunderstorm in the solar system. Lightning without light rain, without sound. Fringe theorists have gone even further. They claim the magnetotail doesn't just deliver oxygen, it alters the moon's chemistry. Over millions of years, they argue those periodic infusions might have created layers of oxidized minerals, a kind of magnetic weathering. Skeptics roll their eyes, but 3-star Atlas recently detected a puzzling signature, brief surges of reflected light near the equator, exactly during magnetotail crossings. Maybe it's coincidence. Maybe it's proof that our planet literally paints its reflection onto the moon every month. You hover closer, imagining the scene in slow motion. Invisible winds of plasma sweep past electrons, spiraling down field lines, curling through space like ghost auroras. If you could see them, they'd shimmer green and violet Earth's northern lights stretching across 250,000 miles. Instead, you feel them through your instruments, faint fluctuations, soft static, the lunar surface vibrating as if brushed by silk. One night in the control room, the 3A Atlas team catches a strange signal, a rhythmic flicker in the magnetometer repeating every 12 minutes. They trace it to the region just beyond the sub-Earth point where the magnetic field lines converge. It's like the moon's heartbeat sinking to Earth, someone says. The data holds for 3 days, then vanishes when the moon exits the magnetotail. It never repeats quite the same way again. Scientists still argue over that event. Some say it was instrument noise. Others think it was a transient electric resonance between the moon's crust and the plasma field, like a tuning fork humming in response to a faraway note. The idea is both absurd and oddly beautiful, a world vibrating in sympathy with its parent planet. As you drift higher, you notice how this relationship feels almost intimate. Every 29 days, the moon enters Earth's embrace, gets charged and recharged, then drifts away again. The exchange is subtle, but constant oxygen for silence, magnetism for dust. It's like an ancient ritual they've performed since time began, invisible but binding. There's a practical consequence too. Those magnetic encounters may protect the lunar surface from solar erosion, preserving fragile traces of volatiles and frost. In effect, Earth shields the moon, giving it periodic nights of peace. Like tucking it under a blanket, one of the engineers joked. You can almost picture it, Earth glowing blue and massive overhead, casting its invisible shroud over its companion, the way you might pull a quilt over a sleeping friend. Still, the moon isn't entirely passive. During each crossing, it reflects energy back into the field. Tiny electromagnetic ripples travel down the magnetic lines toward Earth, sometimes reaching our ionosphere. There's speculation, not proof, that these ripples influence radio signals, a faint echo from the moon's side of the conversation. 3i Atlas is currently testing that theory with synchronized receivers both in orbit and on the ground. It's a strange thought that the next time you lose cell service for a second, it might be because the moon breathed. You stay suspended there halfway between the two worlds, watching the exchange unfold. The invisible aurora of charged particles, the dance of static on grey dust, the magnetic shimmer linking blue and silver. No sound, no light, just motion in the dark. And as you drift further back, you realize the connection is older than life. Long before Earth had oceans or clouds, before weather existed in any form, we know these two bodies were already trading energy tides, magnetism, fragments of air. Maybe that's what weather truly is, a conversation between worlds spoken in heat, light, and charge. You let that idea settle over you like a blanket. The hum of your fan becomes the faint whisper of plasma wind. The glow from your screen becomes Earthrise, painting soft light across your walls. And for a moment you feel the invisible current between you and that ancient companion, the moon, quietly listening, breathing, and waiting to drift back into your orbit. You're still coasting above the moon's pale expanse when something glints near the edge of your vision, a thin arc of yellow light stretching into the darkness like a comet's whisper. It's not a trick of reflection or your sleepy imagination. That's the moon's sodium tail, the strangest rain you've never seen. Every time sunlight strikes the surface, atoms of sodium, yes, the same sodium you'd find in sea salt, get kicked free by micrometeorite impacts and solar radiation. They rise into the exosphere, shimmer faintly, and then drift away, pulled outward by sunlight pressure and Earth's gravity. From far enough away, it looks like a ghostly beam trailing millions of kilometers behind the moon. You could call it weather if you're generous, or a sigh if you're poetic. Atlas calls it the lunar plume. A mainstream fact: astronomers on Earth have actually photographed this sodium tail using specialized filters. It glows faintly yellow during each new moon when the geometry lines up just right. For about 48 hours, our planet literally swims through that invisible mist. Every time you look up at a slender crescent, you're also looking through the moon's exhalation. You drift closer, imagining each sodium atom like a tiny balloon carried off by radiation. No air, no wind, just photons nudging them along. Some stay close to the moon, looping around in lazy arcs. Others escape entirely, joining the trail that stretches millions of kilometers into interplanetary space. It's a one-way journey, the slowest storm ever launched. Scientists still argue whether that sodium comes mainly from solar sputtering or from micrometeorite impacts. Both processes release atoms, but the balance seems to shift with the seasons, or rather with the moon's orbit through the dusty rivers of space. That's why 3i Atlas's long-term data shows sodium seasons. They don't follow months or weather patterns, but meteor showers. During the Perseids or Geminids, for instance, when Earth plows through streams of ancient comet dust, the moon gets peppered with countless microscopic strikes. Each one releases plumes of sodium gas that drift outward, forming what some researchers now call a lunar sodium storm. It's not violent, it's invisible, but it changes the moon's glow. Telescopes have detected brightening sodium lines in those weeks, as if the moon briefly catches fire from the inside out. You picture that from orbit, impacts flashing like camera bulbs, each burst adding a shimmer to the tail. The sodium atoms glow for a moment, fade, and join the exospheric flow. The result is a slow cascade of yellow radiance that wraps around the moon's night side like a halo. If you sped it up, it would look like breath illuminated by headlights, the kind you see when you step outside on a winter night. Somewhere in the data lab, a scientist scribbles moon weather sodium rain on a whiteboard and underlines it twice. Half the team laughs, the other half nods, because it's not entirely wrong. Those atoms follow predictable patterns. They rise and fall with the lunar day surge with meteor impacts and thin again in quiet times. If that isn't weather, what is fringe? Theorists, bless their caffeine-stained courage, suggest that the sodium tail might interact with Earth's upper atmosphere. They claim faint sodium traces have been measured at high altitude right after new moons, as if the two worlds briefly exchange particles. It's controversial, but 3 Atlas's detectors have caught faint coinciding flares like matching heartbeats. The moon exhales, Earth inhales. You hover over the night side where the sodium haze is densest. From this height, it looks like a golden mist hugging the surface. It doesn't swirl or drift, it pulses, glowing brightest near the subsolar point. The pulse matches the rhythm of the solar wind, a solar heartbeat striking the moon like invisible waves. If you could walk through it, you'd see nothing, hear nothing, but your suit's sensors would tingle. The sodium atoms are ionized, slightly charged, brushing against your helmet like invisible fireflies. Every few seconds, one collides with the glass and vanishes, a flash too small to see, but just enough to measure. It's strange to think that the same element that flavors soup and preserves food is also painting cosmic streaks between worlds. Sodium connects oceans and moons, salt and stars. The connection feels symbolic, as though chemistry itself refuses to be lonely. 3i Atlas visual instruments render it beautifully. In the composite images, the tail forms a faint arc stretching far beyond the moon's orbit, glowing against the blackness, like a painter's last brush stroke. You can't help but imagine it moving in time-lapse, a luminous thread weaving through space, reminding you that even silence can leave trails. Scientists joke that the moon is the solar system's slowest comet. A rock pretending to be romantic, one of them said. But when you see that golden ribbon drifting across the void, you realize it's not pretending, it's performing. The same way Earth's clouds change color at sunset, the moon's sodium breath changes hue with the sun's angle, and if you were to watch it from far enough away, say from an observatory orbiting Mercury, you might see both worlds connected by that delicate filament of light. A comet without ice, a storm without sky. It's humbling, really. For all our talk of lifelessness, the moon never stops interacting. It collects it, releases it, paints the dark with its atoms. And every new discovery through Atlas sends back just deepens the realization that the old idea of a dead moon was always a story we told ourselves to make space feel tidy. You lean back in your chair, your eyelids heavy, thinking about that ribbon of sodium. Maybe weather doesn't have to roar. Maybe it can drift quietly for 1 billion years, glowing where no one can see it. And in that moment you feel small but comforted, part of the same chemical breath shared between two worlds that have been trading atoms since time began. You stay in orbit a while longer, letting the moon roll beneath you like a slow tide of grey velvet. The sodium tail fades behind you, and now the surface brightens again with a subtle strobe of impacts, micrometeorites, tiny fragments of ancient comets, falling like an invisible rain. They strike the regolith at tens of kilometers per second, each one a spark in a world that never sleeps. 3 Atlas watches these impacts the way meteorologists watch thunderstorms. Every few seconds, one of its optical sensors records a flash, not bright enough to see with the naked eye, but clear enough for instruments. The data goes into a live display the team calls the dust radar. When they play it back at high speed, the moon looks like it's glittering. Every glint is a collision, a storm cell in miniature. A mainstream fact, even though the moon has no atmosphere to burn up debris, it gets hit constantly by grains of cosmic dust, thousands every minute. Each strike vaporizes a bit of rock-releasing gases like sodium, potassium, and argon. For a few seconds, those gases swell around the impact site, forming a temporary bubble of air, an atmosphere that lives and dies in less than a heartbeat. You could almost call them weather fronts if you had a poet in the lab. The 3 Atlas team likes to say the moon has micrometeor storm seasons. They aren't random. They come when Earth passes through streams of comet debris, the same ones that give us the Perseus, the Geminids, the Taurids. When those grains hit the moon, they create a flash storm of their own, invisible to the human eye but measurable by every instrument sensitive enough to listen. You glide closer to one such event now. A shower of particles pelts the surface like whispers. You can't hear them, but you can see their aftermath, faint clouds of dust lifting glowing faintly under the sun. The surface flickers, the horizon blurs. For a few brief hours, the moon has weather. Scientists still argue whether these microstorms can actually alter the exosphere. Some claim the gas released is too sparse, too fleeting. Others point to 3 Atlas's recent readings showing spikes in sodium density during meteor showers. You can't deny the rhythm, one researcher says. Something's breathing up there, and maybe that's all weather ever is rhythm made visible. There's a strange kind of beauty in these impacts. Each one erases a footprint, smooths a crater, refreshes the landscape. Over millions of years, this invisible rain has polished the moon's face. The same process that destroyed its early atmosphere now maintains its ghostly one. It's both erosion and renewal, violence and balance. You zoom in on one crater floor where a fresh impact has just occurred. The heat still glows faintly red in infrared. Vapors rise, a puff of sodium, potassium and silicon monoxide. Then it's gone. No wind to carry it, no clouds to form. Just a brief shimmer, a silent thunderclap. Fringe researchers sometimes claim these impacts generate enough charge to create localized electric fields, mini lightning storms flickering across the surface. There's no proof yet, but 3 Atlas has detected electromagnetic spikes that appear immediately after impacts. Discharges, one engineer calls them plasma breath. The phrase sticks because it fits. The moon exhaling through heat and shock like lungs of stone. A single micrometeorite the size of a grain of sand can release more energy than a bullet. Multiply that by billions and you get a planet perpetually resurfacing itself, grain by grain, breath by breath. It's slow, patient weather measured not in hours but in epochs. One of the 3 Atlas interns once compared it to snowfall. Each impact, she said, is like a flake landing. You don't notice one, but after a while the ground changes. That metaphor caught on. Now in official logs you can find entries like snowfall rate 10^5, impacts by hour. Science with a touch of poetry. You drift higher again, watching the moon's entire near side under a steady drizzle of dust. It's beautiful in its stillness, but also humbling, the reminder that every surface in space is constantly being rewritten. No place is truly static, not even here. The 3 Atlas data feed overlays the pattern streaks where meteor streams are densest hotspots at the equator, where impacts strike most frequently. Some regions light up like glowing veins, while others sleep in quiet darkness. The pattern shifts over time like seasons. You realize it's not random. The moon has its own meteor climate. That's when a thought hits you. This is rainfall in reverse. On Earth, raindrops fall through atmosphere to feed oceans. On the moon, space itself rains downward, eroding, polishing, renewing. And instead of feeding rivers, it feeds light, the glint you see from your window. When the moon is full, the shimmer that's really just dust freshly turned by 1,000 tiny collisions. Maybe the moon's weather isn't meant to be seen with eyes, but with time. 3 Atlas sees it that way, decades of data layered like tree rings showing cycles of impact and calm. The moon sleeps through its storms, but the evidence remains in its brightness, its glow, its faint sodium tail trailing away like the memory of rainfall. There's one more twist to all this. When those impacts hit, some of the released gas doesn't escape immediately. It lingers trapped by static or gravity, forming what scientists call a transient atmosphere. For a few moments the moon breathes thicker, and 3 Atlas has recorded these moments' subtle but unmistakable pulses in density. The data looks like a heartbeat drawn in light. You smile. A storm that lasts 3 seconds. An atmosphere that lasts an instant. A heartbeat carved in dust. Maybe that's all the moon needs to prove it's alive. Above you the stars remain steady. Below you a grey world continues to shimmer. You close your eyes, and for a second you swear you can feel the impact's faint taps against your awareness like distant rain on a tin roof. Except this time it's not rain. It's eternity falling grain by grain. You float above the highlands now where craters overlap like fingerprints pressed into ash. The surface below looks still almost meditative, but 3R Atlas knows better. It can feel the tremors. The moon moves not fast, not often, but deep. Every few days the sensors record a small shiver, a ripple running through bedrock that shouldn't be moving at all. The scientists call them moonquakes, and they may be the closest thing to a lunar breeze. It sounds poetic, but it's true. Moonquakes release more than seismic energy. They disturb gas pockets trapped beneath the surface. Every vibration sends fine dust drifting upward, invisible but measurable like breath exhaled from stone. The moon doesn't rumble the way Earth does, it sighs. A mainstream fact: the Apollo seismometers left on the surface between 1969 and 1972 detected 4 types of moonquakes. The deepest ones, likely caused by gravitational pull from Earth, happened hundreds of kilometers down. Others came from meteor impacts or thermal cracking at sunrise. But the most mysterious were the shallow moonquakes, sharp jolts, sometimes strong enough to move boulders. One quake in 1972 lasted more than 10 minutes. Scientists still argue whether they were caused by tidal stress or something else entirely. 3I Atlas's newer instruments picked up something those early seismometers missed: faint synchronized bursts of gas following certain tremors. Tiny temporary increases in argon and radon concentrations, volatile fingerprints of a living crust. They called it the seismic breeze. You hover lower, watching one unfold. Deep beneath you, a stress line shifts. The surface trembles imperceptibly, a slow flex that cracks microscopic cavities open. Trapped gases rush upward, stirring the dust. It's not air, but it moves as if it were. For a few minutes, the regolith lifts in graceful arcs, then settles again. The sensors note a temperature, spike a static pulse, a faint movement of particles along the slope. Then silence returns. You can almost imagine standing there, feeling the ground shift beneath your boots. No sound, just a sudden lightness, as if gravity blinked. A puff of dust would rise, the horizon would shimmer, and you'd feel that ancient stone inhale, before exhaling once more. Fringe researchers have suggested that these moonquakes might even influence the moon's weak magnetism, creating short-lived electromagnetic fields that flicker like northern lights under your feet. The data is controversial, but 3I Atlas has indeed recorded coincident magnetic spikes. Something's coupling energy down there, one analyst said. Maybe pressure converts directly into current. That idea intrigues everyone because it means that every quake, however small, could charge the dust, above triggering more of those electrostatic fountains you saw earlier. Weather and geology linked, the moon's breath and its heartbeat working together. You look down again. A fracture runs across the landscape, sharp and dark. Over it lies a subtle haze, the aftermath of one of these quakes. The particles glint faintly caught in electric charge before settling like snow. It's eerie and beautiful, like frost forming on breath. Here's a mainstream detail that sounds like fiction. During the 1972 Apollo 17 mission, seismic readings spiked near the Taurus Littrow Valley without any known cause. Hours later, orbiters detected a faint cloud of gas rising from the same region. NASA labelled it a transient lunar phenomenon. Some thought it was a coincidence, others quietly logged it as proof that the moon occasionally exhales. 3i Atlas later confirmed that the same area still shows bursts of radon every few years. The old instruments were right all along. You float closer to the valley, imagining those invisible eruptions like breath escaping from cracks after eons of silence. They're small, harmless and slow, but they remind you of volcanoes that forgot how to roar. Weather without wind. Scientists still debate the origin of that gas. Some believe it's trapped from ancient volcanic outgassing. Others suggest micrometeorites and solar radiation break down minerals, releasing atoms over time. Either way, the result is the same: the moon breathes through its scars. 3 Atlas uses its thermal images to track these events in real time. You can see one on the screen now, a faint plume just a few meters tall drifting upward before disappearing. In that instant, the lunar exosphere thickens slightly. Dust moves, electricity stirs. It's the smallest storm imaginable, but it's there. There's an odd poetry to it, an airless world that still manages to weather itself. Rocks that shiver, gas that rises, dust that drifts. No clouds, no thunder, just patience. Millions of years of patience. One of the scientists, an older geophysicist with a dry sense of humour, once described the process this way: it's like the moon burping in its sleep. Everyone laughed, but she had a point. Those micro-burps keep reshaping the landscape. Over geologic time, they loosen rocks, scatter dust and mix layers. The moon is sculpting itself from within, breath by breath. You drift upward again, the curvature of the surface expanding beneath you. For a brief moment, you imagine you can hear it, a low hum, the resonance of rock and dust moving ever so slightly. It's not really sound, of course, but your brain insists on translating vibration into melody. The moon's hum becomes a lullaby. You close your eyes and feel its rhythm, slow, deep content. Somewhere below, a fissure breathes gas into silence. Somewhere else, a dust fountain dances. The moon is alive, not in the biological sense, but in the way deserts are alive, glaciers alive, volcanoes alive. Motion at the edge of stillness. And as you drift in that hum, you realize the truth. 3i Atlas has been chasing all along, even in the absence of air weather finds a way. It just hides in stone. You drift along the moon's northern rim now, where shadows move like tides, sliding inch by inch, across a land that never really wakes. Up here at the poles, sunlight is a visitor that never fully arrives. It just skims the horizon forever. The result is a strange perpetual twilight that never grows warm and never entirely darkens. The scientists at 3i Atlas call this place the line of eternal dawn. From orbit, it looks serene. But what you're seeing is motion, slowed beyond imagination. Frost-forming, melting, reforming molecules migrating grain by grain. These are the moon's cold traps. The same craters you visited earlier, but now viewed in their wider rhythm, their daily cycle of shadow and shine. The sun here never rises higher than a fingertip's width, yet that faint glow is enough to stir frozen gases, making them creep across the surface like ghost tides. A mainstream fact in these polar regions, temperatures can vary from 230 degrees in shadow to 50 degrees in sunlight. Even that slight difference creates gradients strong enough to shift water molecules across the soil. Over weeks, the frost moves, vanishing from one rim and appearing on another. Lunar orbiters have tracked this migration using infrared scans, proving that the frost is not permanent. The moon has seasons invisible to the eye. You descend closer, hovering just above a crater lip. The light here comes sideways, sharp and metallic. The ground sparkles as frost crystals catch those few rays and glint like scattered mirrors. Then the sunlight slides away and they fade back to invisibility. The motion is so slow it's hypnotic. 3i Atlas's sensors register a subtle rise in temperature as the light returns. That warmth frees a handful of frozen molecules trapped in the upper regolith. They leap into the vacuum drift a few meters and refreeze somewhere cooler. It's migration without wind weather, without air. You could call it the moon's frost tide. You remember what an astronaut once said about the surface. It's like walking through gunpowder that wants to fly. Here it's more delicate dust and frost entwined in a chemical dance. The charged particles make frost cling to certain grains and repel from others, creating thin filigree patterns that 3i Atlas imaging radar captures like frost flowers etched in metal. Fringe researchers love those patterns, Some believe they reveal hidden energy flows, microcurrents, running through the regolith, guiding how frost forms. They argue that the moon's internal electric field acts like a weather vane steering molecules towards certain mineral-rich spots. Others call that fantasy, but the data's there, subtle asymmetries that no random process should make. It's as if the frost remembers where to land, one physicist murmurs during a late shift. You glide over a particularly beautiful patch, now a slope, glimmering faintly blue with dark streaks where frost has receded. The streaks align almost perfectly with the magnetic field lines measured earlier. Coincidence, maybe? Or maybe the moon has its own kind of magnetic weather map. Here's the mainstream twist: some of these cold traps aren't permanent. Over millennia, the moon's axial tilt wobbles slightly, shifting how sunlight reaches the poles. As it does, old shadows die and new ones form. Ice that was trapped for billions of years melts away, migrating to the new dark zones. So even here, in the stillest part of the solar system, landscapes evolve. The moon's face breathes in slow motion. You can feel it through the data stream, the temperature fluctuating by fractions of a degree, the spectral signature of water changing hour by hour. It's the gentlest storm imaginable, one that happens too quietly for eyes, but not for senses. And Three-Eye Atlas listens like a doctor with a stethoscope pressed against ancient bone. Every molecule that escapes leaves a trace. Every shift in reflectivity marks another exhale. In the archives, you can watch these records play out in color blue for frost forming red, for frost vanishing. If you compress 10 years of data into a minute, the polar craters seem to shimmer like breathing lungs. One of the younger analysts once said it looks alive. An older colleague smiled. It is, just not in our kind of time. The moon keeps its own pace. Its frost doesn't rush. It wanders. Sometimes on long nights in the control room, the scientists give names to these wandering frost flows: the Slow River, the North Vale, Crater, Nine's Whisper. It's a kind of affection, the same way ancient sailors named winds. If you listen closely, really listen, you can almost hear it. The faint creak of thermal change, the whisper of ice sublimating the hum of distant electricity. It's the music of stillness measured in centuries. You drift lower again down into a half-lit hollow where shadow swallows sound. Frost gleams on the rocks like breath on glass. For a moment you feel the illusion of standing inside an exhale, frozen mid-air. It's not a dream. It's the real rhythm of the lunar pole's heat rising cold, answering the two trading places forever. Scientists still argue whether these migrating frosts can support future colonies. Some say yes, harvestable ice renewable in its own way. Others warn it's too thin, too delicate, too sacred to disturb. Three-Eye Atlas doesn't choose sides. It just watches patient as the moon itself. You hover in that calm and the thought drifts through your mind that maybe this is what weather looks like in eternity: no storms, no clouds, just light sliding endlessly across ice and shadow. You can almost feel your breathing sync with it, slow, steady, ancient. And as the moon turns beneath you, the eternal dawn moves one crater farther, melting one frost patch and freezing another. The tide continues, the rhythm holds, and somewhere in the data logs another pulse gets recorded, the heartbeat of a world that refuses to stop changing no matter how quietly. You hover just above the rim of Peary Crater now, where the sunlight glances off the surface like a blade. Down below in that dim grey valley, something glimmers, faintly delicate, crystalline, almost floral in shape. Three-Eye Atlas calls them transient ice dendrites, but the nickname the crew prefers is far simpler: lunar frost flowers. They appear only during the brief windows when sunlight and shadow overlap, moments of just enough warmth for sublimation and just enough cold for refreezing. Molecules freed from the soil lift a few centimeters into the vacuum drift sideways and settle again on colder grains. In that silent migration, geometry happens. The vapor traces branching patterns, forming microscopic spires and petals. No one has ever seen them with eyes, but the instruments don't lie. Radar reflections scatter in fractal signatures that can't be random. A mainstream fact scientists already know: frost can form on airless bodies. In 2017, NASA's Lunar Reconnaissance Orbiter found spectral hints of surface frost at high latitudes, likely concentrated on shadowed slopes that see only glancing light. Three-Eye Atlas went further, detecting cyclical changes in reflectivity patterns that repeat like growth and decay. If you sped them up, the craters would seem to bloom and wither once every lunar day. Imagine standing there at dawn. The sun barely grazes the horizon, the sky black as obsidian. Beneath your boots, A thin glaze of frost begins to sparkle. It doesn't melt. It sublimates, shifting straight from solid to vapor. The vapor curls invisible except for the faintest shimmer, then freezes again a few meters away. It's like watching breath crystallize in slow motion. You could wait hours to see a single glint change position, but change it would. The team at 3 Atlas once joked that the moon grows a garden every morning only to erase it by night. There's something heartbreakingly poetic about that creation and disappearance endlessly repeating. It's weather in bloom, one analyst said softly during a briefing. No one laughed that time. Fringe theorists, always ready to stir things up, propose that these frost patterns aren't entirely random. They suggest electromagnetic forces guide the branching, just as electrical fields shape snowflakes on Earth. The idea seems outlandish until you remember the moon's surface voltage swings hundreds of volts each dawn and dusk. 3 Atlas has recorded faint repeating patterns, in those fields circular currents like invisible petals of charge. If frost follows those paths, the moon might indeed be painting itself with electricity. You picture it now, billions of microscopic crystals forming a lace veil across the grey soil, tracing magnetic loops that shimmer for just an hour before vanishing. No air, no scent, no dew, only silence and geometry. A mainstream observation worth whispering here: sunlight on the moon carries no warmth at first touch. It's pure radiation, unforgiving and sharp. Frost flowers form where the light angles too shallowly to burn where the ground stays just below freezing. There, sublimation and condensation exist in fragile balance. That balance is the very definition of weather difference seeking equilibrium. The 3i Atlas monitors these regions obsessively. Each rotation the same spots brighten, fade and brighten again. It's not random noise, it's rhythm. A garden of time. You drop lower until the frost glints fill your field of view. They look like stars scattered on stone. For a fleeting instant you realize this is the only place in the solar system where stars rise from the ground instead of the sky. You almost reach out though, your hand would pass through vacuum and nothingness. Still, it feels sacred, a moment of living stillness. The scientists keep debating what happens to these crystals over millions of years. Do they build up? Do they vanish entirely? Some say micrometeorite impacts recycle them, smashing and redepositing molecules. Others think a thin, permanent layer of trapped ice forms deep down, locking ancient frost beneath younger frost, an archive of seasons too long for us to grasp. 3i Atlas is currently testing that with radar scans that penetrate a few meters below. Early results show layered echoes. If those layers are real, then the moon has a memory. You tilt your perspective and notice something else. The frost isn't evenly distributed. It clusters around certain magnetic swirls regions where local magnetic fields shield the surface from solar wind. These lunar swirls, such as the famous Rena Gamma, gleam brighter even at night. Their surfaces less weathered, their frost more persistent. Perhaps the magnetic shield lets the crystals last longer, preserving their delicate shapes. It's microclimate without air magnetic weather zones on a world that shouldn't have any. Scientists still argue how those swirls formed. Some say they're relics of buried iron-rich rock. Others think they're scars from ancient comet impacts that magnetized the ground. Either way, they alter how frost grows, creating shimmering patches that seem to defy logic. 3i Atlas has been mapping them in ultraviolet light, producing images that look more like coral reefs than craters. You hover higher, letting the view widen. The frost flowers fade into silver haze, the magnetic swirls into faint arabesques. The whole landscape seems alive now, a tapestry, shifting one grain at a time. There's no wind to tear it apart, no rain to wash it clean, just light magnetism and patience. If you listen carefully beneath the hum of instruments, you can almost imagine a whisper. The moon's softest song sung through ice and dust. I do not sleep. I rearrange myself. You breathe slower, sinking to that tempo. Maybe that's all weather really wants, not chaos but rhythm, not drama but continuity. The frost below shimmers one last time as the sun climbs higher. The flowers vanish, leaving only memory, and the certainty that they'll bloom again precisely on schedule in a place that isn't supposed to change but always does. Night has returned to the lunar mid-latitudes, though. Night here is a relative thing, an endless stretch of darkness lasting 2 Earth weeks. You float over the boundary between that night and the faint dawn beginning to crawl across the far horizon. 3i Atlas's ultraviolet cameras are open, their sensors wide awake, waiting for something that shouldn't exist on a dead world aglow. It begins as a faint film over the surface, too dim for human eyes. Then just above the line where shadow gives way to light, an electric shimmer blooms bluish ghost-like alive. The Apollo 17 crew saw it first back in 1972. They described it as a soft bluish mist lifting from the ground and forming a low arc across the horizon. It looked like twilight back home, one astronaut said. Except home had air. For decades nobody knew what they'd seen. Sunlight scattering through dust static discharge optical illusion. Scientists still argue whether the glow is reflection, fluorescence, or something stranger. But 3i Atlas, with instruments far more sensitive than any camera humans carried, sees patterns that suggest order. The glow intensifies exactly where electrostatic fields are strongest, then fades as the lunar night deepens. You watch the data cascade across the monitors, bright streaks tracing the terminator, pulsing faintly like a heartbeat. The moon isn't just reflecting sunlight, it's emitting something. The detectors pick up low-energy electrons streaming upward, colliding with the thin exosphere. Each collision releases a photon, tiny flashes of ultraviolet light that add up to a visible sheen. In essence, the moon glows because it's buzzing with electricity. It's easy to imagine this as a kind of aurora Earth's quieter cousin. But here there are no magnetic poles, no roaring solar winds sweeping curtains of light. This is lightning in whispers, static trapped in dust. A mainstream fact ultraviolet spectrometers aboard NASA's LADEE mission recorded unexpected flashes of light just above the lunar surface matching the old Apollo descriptions. When those results were combined with 3 Atlas measurements, they revealed a repeating pattern tied to lunar sunrise and sunset. Every dawn and dusk, the electric potential across the surface jumps, releasing faint, ghostly luminescence. Fringe theorists love that idea. They claim it's a relic of ancient magnetism, pockets of charge still circulating through buried iron deposits. Some even speculate the moon once had a magnetic dynamo long extinguished but not entirely gone. If so, these blue nights might be its last echo. You drift closer, letting your sensors paint the darkness. From this height the glow appears patchy, brighter near certain magnetic swirls, fainter elsewhere. It's as if invisible rivers of charge run across the surface, glowing where they gather, fading where they disperse. The landscape becomes a slow-moving constellation, the ground pretending to be sky. Imagine standing there, helmet visor reflecting that soft blue haze. Your shadow would flicker faintly, edges haloed with light that doesn't belong. There'd be no sound, no wind, but your suit's static sensors would hum with voltage. If you reached out a gloved hand, you might see sparks crawl across your fingertips, harmless but eerie, a silent reminder that the moon is never truly asleep. 3i Atlas. Once captured a burst so strong it triggered automatic safeties. For 8 seconds, sensors registered a field strength high enough to lift dust several centimeters into the air. Then it collapsed. The images showed a shimmering plume that looked like fog dispersing in water. "We just saw lunar lightning," one engineer whispered. Everyone laughed at the exaggeration, but nobody turned off the recorder. Scientists still debate what fuels these flickers. Some say the glow comes from sunlight energizing trapped electrons in lunar soil. Others insist it's the solar wind striking directly. A few propose something stranger, that the glow occurs when dust particles collide mid-air, releasing tiny flashes like static sparks between clothes fresh from a dryer. 3i Atlas has captured evidence for all 3, but none of them fully explain the timing. It's possible the team admits that the phenomenon is multiple things at once, physics improvising a symphony of charged dust, trapped plasma, and faint fluorescence. The result is what they now call electric blue nights. You rise higher until the view widens into a single glowing crescent. From this distance, the light looks steady, tranquil. It's easy to mistake it for reflected sunlight, but you know better. You know it's electricity turning into colour, an atmosphere being born and dying every night. Down in the control room, someone adjusts the brightness of the live feed and whispers, "It's like the moon is remembering daylight." You nod, even though they can't see you. That's exactly what it looks like, a memory replaying itself in photons, and as the dawn line creeps across the surface, the glow fades. The voltage drops, the dust settles, the moon returns to its pale silence. But you can't unsee it now, the flicker that means life in another language, a pulse spoken in ultraviolet. Maybe that's what all weather is, a reminder that even stillness needs an outlet. The monitors dim, your breathing slows, and for a moment you feel the static hum in your ears. the sound of a world turning its own version of aurora into lullaby light. The moon glows, sighs, then rests. You do the same. You're still gliding above the hemisphere that faces Earth, but tonight the light behaves differently. The moon's glow has quieted its ultraviolet shimmer, fading into patches of strange brightness and shadow. Fifon Atlas calls these places magnetic whirls, swirls of remnant magnetism that twist the solar wind and scatter charged particles like invisible currents. The most famous of them, Reiner Gamma, lies below you now, a bright coiling mark on a plain of grey basalt. From here it looks painted on like a brushstroke frozen in dust, but this is no illusion. The magnetic field there, though, weak by Earth standards, is strong enough to deflect the solar wind. Where it shields the ground, the surface stays younger, less weathered, brighter. It's the lunar equivalent of climate a sunburn map drawn by magnetism. A mainstream fact scientists have long puzzled over these magnetic anomalies. Unlike Earth's magnetic field, which comes from a molten core, the moon's is local, patchy and ancient. Some regions hold a magnetic charge up to 100 times stronger than their surroundings. The prevailing theory says that billions of years ago, powerful impacts magnetized the crust while it was still hot. The result is a world divided into tiny magnetospheres, each bending the solar wind in its own direction. You drift lower, watching 3i Atlas's magnetometers paint lines of force across the terrain. They loop and curl like smoke rings, forming shapes that mimic weather fronts. Charged dust follows those lines, drifting sideways instead of up. When sunlight hits, you can actually see the faint difference. A glow tracing magnetic boundaries like storm fronts on a weather map. Fringe researchers have a phrase for this magnetic weather. They imagine the moon's surface as a quilt of competing microclimates, each ruled by its own magnetic swirl. Within these zones, dust grains charge and discharge differently, creating slow-moving currents that migrate like winds across invisible borders. 3i Atlas's instruments lend cautious support, tiny but consistent electrical variations that pulse with the lunar day. Imagine landing within one of these whirls. Your boots would step into powder so fine it behaves almost like smoke. The regolith there might stick to one leg of your suit but not the other, drawn to unseen fields. Your instruments would show voltage oscillations without apparent cause. And if you looked up, you might see faint luminescence tracing the magnetic pattern across the ground, a ghostly aurora lying flat instead of hanging in the sky. Here's the quirky twist. The Reiner Gamma swirl, despite having no elevation change, is one of the brightest features on the moon. Its brightness confounded early observers. Some thought it was a fresh crater, others a trick of light. It's none of those. It's weathering, or rather the lack of it. Where magnetism shields the surface from solar wind iron in the soil, stays metallic rather than oxidized. It reflects sunlight like polished steel. The moon's magnetic swirls are literally self-preserving areas immune to aging. You can see that in the data the edges of the swirl blur, gradually showing where protection fades and normal space erosion begins. It's like watching the border between clear and cloudy sky. 3 Atlas scientists overlay those contours with dust transport models, and what emerges looks startlingly familiar, a forecast map. You could almost call it the lunar jet stream, one analyst jokes. Everyone chuckles, but then the laughter dies because the pattern is too convincing. Scientists still argue about the deeper cause. Some think molten metal once flowed beneath these regions, creating magnetic streaks like iron veins. Others suggest ancient comets left trails of plasma that magnetized the crust on contact. 3i Atlas's readings complicate things further. They show the fields fluctuate ever so slightly, with solar cycles implying something below still reacts however faintly. That thought lingers, a magnetic heart still beating under rock. If that's true, then the moon isn't just preserving weather, it's making its own. You imagine the effect from Earth's perspective. Every time a gust of solar particles slams into the moon, these magnetic whirls twist the flow, scattering it like wind over mountains. Part of the deflected plasma arcs away towards space. Part slips into quiet eddies that circle the anomalies for days. Dust caught in those loops follows the field, creating slow spirals visible only to ultraviolet eyes. The moon, it turns out, has storms after all, so slow they last centuries. The 3 Atlas team once projected these currents in a simulation. On the big screen, the lunar surface looked like an ocean seen from above, with bright magnetic swirls spinning like eddies in dark water. It's weather frozen in metal, someone said softly. A map that never changes except it does. You float higher, the entire pattern unfolding beneath you, a mosaic of bright arcs and dim planes, each shaped by forces older than continents. From this height, the moon looks alive with fingerprints of magnetism. Each swirl, each bright patch tells a story of energy once molten, now fossilized yet not entirely still, and you can't help but feel a quiet respect for it. The moon may no longer roar with lava or hiss with air, but it still hums with electricity, still weaves invisible streams through dust and light. Its magnetic weather doesn't rage, it murmurs. In the silence of your room, the hum of your fan becomes the echo of those invisible currents. You breathe in time with them, slow, even magnetic. Somewhere between heartbeats you realize that weather doesn't need to be loud to exist, it just needs contrast, force meeting, resistance, motion, finding balance. Below you, Reiner Gamma gleams one last time before lunar night rolls in again, and the swirls fade into darkness. But their fields remain unseen, and eternal shaping dust, light, and time itself. You remain above the swirls a little longer, watching the faint traces of magnetism fade into the shadows. From this distance, it almost looks like a ripple in water that refuses to settle. That illusion, something rising, falling, breathing, captures exactly what 3i Atlas has spent years trying to describe the dust fountain hypothesis. It sounds whimsical, like something that belongs in a planetarium gift shop, rather than a scientific journal, but it's real enough to divide entire conferences. The idea is simple yet strange. When sunlight strikes the moon, it electrifies dust until the grains literally levitate, forming invisible fountains that rise and fall with the light. The debate, of course, is about scale. How high do they rise? How long do they last? And can something that's subtle truly count as weather? A mainstream fact, Apollo orbiters photographed odd, bright halos on the horizon during lunar sunrise as if sunlight were reflecting off airborne particles. Later, NASA's LADEE spacecraft confirmed bursts of dust tens of centimeters above the surface. The data fit the theory electrostatic forces strong enough to lift fine grains. 3i Atlas, with newer sensors, has gone further, detecting vertical dust movement up to several meters high, repeating daily. You hover just above one such region, where the local magnetic field is weak, and the sunlight hits at a shallow angle. The ground below flickers faintly. Dust grains, some smaller than smoke particles, lift from the surface in slow motion. They drift upward, reach an invisible ceiling, then fall back like featherweight rain. You watch them repeat endlessly, like the moon's own respiration. Scientists still argue whether these fountains are continuous or episodic. Some claim they pulse with the lunar day, others believe they erupt like geysers after long periods of charge buildup. 3i Atlas has detected both rhythms, one steady, one spiking, and neither fully explains the phenomenon. It's as if the moon can't decide whether to breathe calmly or sigh dramatically. You imagine standing there on the surface just before sunrise. The darkness is total, but your visor's HUD flickers with electrical readings, voltages, building fast static, charging every surface. Then as the first ray of sunlight hits you, feel a gentle upward pull. The dust around your boots stirs, hovers, glitters faintly, like dry snow caught in moonlight. You stretch out your hand and it feels as though the ground itself is humming, the quirky twist. These fountains might be responsible for slowly transporting dust across the entire lunar globe. Over billions of years, electrostatic lifting and settling could have redistributed the regolith, explaining why some craters look smoother than others, despite constant impacts. The moon, it turns out, may clean and rearrange itself very slowly but endlessly. There's even an internal nickname among the 3i Atlas crew: the moon sweeps its porch. Every sunrise a soft lifting, every sunset a quiet settling. If you speed up the simulation, the whole surface ripples dust flowing like liquid. The illusion is breathtaking. Fringe researchers, because there's always at least one, argue that these fountains aren't just caused by static, but by deeper electrical circuits connecting the moon to the solar wind. They imagine the moon as an electrode in a planetary-scale plasma network, drawing and releasing energy. To them, the dust fountains are lightning slowed to the tempo of geology. If you stretch a lightning bolt over a day, one said you get the moon. That statement made the official transcript, though it earned a row of raised eyebrows. Still, 3i Atlas can't completely dismiss it. Some readings show synchronized voltage spikes across distant sites, as if the fountains communicate through the crust. The effect is subtle, yet consistent. When one region brightens, another dims. When one fountain rises, another falls. You glance down again. The surface is alive with tiny motions, too small for eyes, but visible in your imagination. It's hypnotic. Dust grains leap upward, glint in sunlight, then drift back in graceful arcs. its motion stripped of chaos, weather boiled down to its essence balance. Here's the mainstream analogy that makes scientists smile. These dust fountains behave almost exactly like the way air molecules bounce in an atmosphere, just slower, quieter, exaggerated by vacuum. The moon, in a sense, has an air of its own, only made of dust instead of gas. That's why 3 Atlas treats it as meteorology, not just geology. It's not about atmosphere, it's about movement. The data graphs even look like weather charts. Peaks at dawn, dips at noon, another spike at dusk. A lunar day breeze. That phrase made it into one of their papers, and someone later printed it on a mug. Never underestimate an airless world, the slogan reads. You smile at that because it captures the essence of this entire mystery, that silence doesn't mean stillness. The moon's fountains are proof that energy finds expression even in emptiness. Every photon that hits its surface gets turned into motion dust, leaping light, scattering voltage, balancing. It's the most delicate storm you'll never feel. The 3i Atlas simulation lab once rendered it in 3D. The room filled with a holographic cloud of particles, each glowing softly as it rose and fell. For a few seconds, everyone stood quietly mesmerized. That's it, the director said. That's the breath. And that's exactly what it feels like now, hovering above it. You breathe slower. The dust below breathes with you. Each exhalation lifts the grains. Each inhalation settles them. The moon's weather is so faint that only patients can detect it, but once you do, it changes everything you thought you knew about stillness. If weather is motion in search of balance, then the moon has had the same goal for 4 billion years. It just happens to chase it one grain at a time. You leave the fountains behind and drift farther into the lunar night where the stars hang sharp and unmoving. The silence feels absolute until the sensors of 3i Atlas remind you that even here something subtle is happening. For a few days each month, when the moon passes behind Earth, an invisible thread connects them. Oxygen stolen from our own planet's upper atmosphere hitches a ride along magnetic field lines and lands softly on the moon's surface. The phenomenon has a beautiful, improbable name: oxygen transfer through the magnetotail. A mainstream fact, the Japanese Kaguya orbiter first detected this strange exchange in 2017. When the moon moves through Earth's magnetotail oxygen, ions from the planet's ionosphere travel across that magnetic bridge. They fall onto the moon's night side, embedding themselves in the dust. 3i Atlas confirmed it later. The isotopic ratios match Earth's perfectly. Every month, a few million tons of our own breath dust the moon's surface. You imagine it now, a stream of ghost particles flowing silently from blue to grey. Earth exhales. The moon inhales. The effect is subtle but measurable. A slight increase in oxygen levels, a softening of surface charge, even a change in how dust behaves under light. It's the closest thing the two worlds share besides gravity. Scientists still argue what happens to that oxygen once it lands. Does it bond with metal oxides in the soil? Does it bounce off into space? Or does it linger just long enough to mix with hydrogen from the solar wind, forming fleeting traces of water? 3i Atlas leans toward the third idea. Its spectrometers detect faint bursts of hydroxyl molecules during each magnetotail crossing, flashes of chemistry gone within hours. You look down at the moon's dark side, knowing that right now it's covered in a thin veil of terrestrial breath. If you were standing there, your boots would crunch into dust touched by Earth's own oxygen. You'd leave a footprint that's half lunar, half home. The idea unsettles and comforts at once. For billions of years, these two worlds have been trading gifts, tides light energy, but now you realize the exchange is literal. The air you breathe leaves traces on the moon every month. The moon in turn reflects light that grows crops, guides, migration-shaped stories. It's a feedback loop written in physics and poetry. 3i Atlas researchers like to describe it as Earth weather extended. They mean that our magnetosphere, vast and dynamic, doesn't end where we think it does. It reaches out to touch the moon, delivering its own form of seasonal variation. There are nights when the magnetic wind is strong, saturating the lunar surface with ions. Other months it's weak, leaving the dust brittle and dry. To an imaginative observer, it's rainfall and drought conductivity, and calm lunar weather driven by Earth's pulse. Fringe theorists have even proposed that the moon accumulates these oxygen atoms in layers, forming faint chemical strata that could one day be read like tree rings. They tell the story of our atmosphere, the rise of oxygen from photosynthetic life, volcanic ash, even human industry. a frozen record of Earth's air archived by the moon's patience. Every footprint is a fossil of breath one essayist wrote, and 3i Atlas quietly adopted that as an unofficial motto. You drift closer to the surface again, scanning one of the oxygen zones. The soil there glows faintly more reflective than usual, a quirk of altered chemistry. It's as if the moon blushes each time it receives our touch. If you could watch the process in time-lapse, it would look almost like weather. Streams of oxygen descend invisibly, mix with dust, react with solar particles, then fade. The pattern repeats monthly. The moon doesn't have an atmosphere, but it borrows one for a few days at a time, wearing it like a borrowed coat before returning it to the void. Here's the quirky twist. 3i Atlas detected something unexpected during one of these crossings. The oxygen ions didn't just land some rebounded, spiraling outward and forming a temporary halo around the moon. For 2 days, instruments recorded an increased density of particles enough to act like a miniature atmosphere. When light hit it, it scattered faintly the first measurable moonlight haze caused by Earth itself. Scientists still debate how dense it was. Some estimate just a few hundred molecules per cubic centimetre, thinner than any vacuum on Earth, yet enough to count. For 48 hours, one researcher said the moon caught its breath. You can almost see it now, Earth's magnetotail washing over the moon like an invisible tide. The sodium glow from earlier, the dust fountains, the static charge all shift in response. The whole system pulses in sync like lungs sharing air. It's humbling to realise how far that connection goes. We think of the moon as distant, but it's constantly inside Earth's influence, pulled by gravity, brushed by magnetism, dusted by oxygen. It's our weather made cosmic. You close your eyes for a moment and picture that bridge of particles, blue ions leaving the upper atmosphere, drifting silently through 400,000 kilometres of space, landing on silver dust. No wind, no sound, just exchange. It's delicate and deliberate, the way tides touch the shore. In the end, maybe that's what all weather is. Movement between opposites. Warm to cold, light to dark, Earth to moon, each side feeding the other endlessly. You breathe out, and somewhere in a few days' time, a few of those atoms might join that stream-riding magnetism toward a crater older than life. It's a strange thought, but strangely comforting, that even in sleep you're participating in a pattern older than air itself. You remain on the moon's night side a little longer, coasting above craters that gleam faintly in reflected Earthlight. The surface looks calm, powdery and pale, but the instruments on 3i Atlas pick up something uneasy beneath the stillness, little bursts of energy that flicker like nerves misfiring. For decades, people whispered about lunar lightning. Most scientists dismissed it as fantasy, but the more the sensors listen, the harder it is to ignore the tremor in the data. No one is claiming bolts in the sky or thunder rolling across the vacuum. This lightning has no flash, no crack, no air to carry its sound. What it does have is charged electrostatic energy built up in the soil, released in quick pulses that dance invisibly from rock to rock. Think of it as the spark you feel when you touch a doorknob after walking on carpet, only stretched across kilometers and lasting for hours. A mainstream fact: when Apollo astronauts returned from the moon, they reported that the dust clung stubbornly to everything, even to metal surfaces that should have grounded easily. Later measurements showed why the lunar surface can hold a charge of hundreds of volts between light and dark regions. Where those boundaries meet, discharges can occur. They're tiny, transient, but real. NASA even recorded brief pops of radio static during lunar sunrise, believed to be these silent sparks snapping through the regolith. 3 Atlas records them constantly. To the instruments, they look like tiny magnetic hiccups, short bursts of current that ripple through the ground, rise into the exosphere, then vanish. Most last less than a millisecond. Some repeat rhythmically, others appear in clusters. The team calls them dry lightning events. You hover lower, just above one of the hot zones, a flat plane where the contrast between sunlight and shadow is sharpest. Down below, nothing moves, yet the sensors show the soil alive with electric motion. Positive charges build in the dark, negatives in the light, and where they meet, sparks leap invisibly through dust. The ground glows faintly in ultraviolet, an aura too weak for eyes, but bright on 3i Atlas's screen. Scientists still argue about the trigger. Some say it's pure electrostatics. Others think seismic vibrations or micrometeorite strikes help release trapped charge. A few go further, suggesting the moon's crust behaves like piezoelectric quartz, generating voltage whenever it's strained by gravity. That idea sounds fanciful until you realize the moon flexes constantly under Earth's pull. Each orbit stretches it a few centimeters, enough to produce current if the rocks are right. You picture it now, a sphere of dust and rock, flexing imperceptibly under invisible tides, releasing faint sparks across its surface, like neurons firing in slow motion. It's not thunder, but it's something close lightning without the storm. A quirky observation during one magneto-tail crossing, 3I Atlas, detected a cluster of these discharges perfectly synchronized with Earth's auroral activity. As green lights danced over the Arctic, silent electric flickers raced across the lunar soil. The data made headlines for about 2 hours before skeptics buried it under words like correlation. Still, no one could explain the timing. Maybe the moon just likes to answer, one researcher said, half serious. You zoom out now, the entire hemisphere glowing faintly in ultraviolet as those micro-discharges cascade like distant lightning behind clouds. The light doesn't streak, it ripples tiny pulses spreading in waves. It's the slowest storm imaginable, a ballet of electrons too quiet for sound. Fringe theorists, ever unafraid of drama, believe these pulses might even produce faint visible glows, the same transient lunar phenomena reported by astronomers for centuries. Red or white flashes seen from Earth flickering for seconds. Most were dismissed as optical illusions, but 3I Atlas's records of high-voltage spikes line up suspiciously close to some historical sightings. Perhaps those old observers weren't imagining things after all. You descend toward a crater rim where one of these pulses just occurred. The soil looks untouched, but the data shows a brief temperature jump, maybe from the energy released as dust grains collided and discharged. The surface breathes heat into the vacuum, then cools again, the same way a lightning strike warms air back on Earth. The moon copies the motion, just slower, quieter, stripped of spectacle. It's humbling to think that even in total silence, the laws of electricity still find ways to express themselves. Weather in clouds or dust voltage insists on movement. The moon may have no weather as we define it, but it still seeks equilibrium. Every spark is a tiny protest against imbalance, a microcosmic storm demanding release. 3I Atlas's engineers have started to map these discharges as if they were lightning strikes, plotting them in clusters, giving them playful names: the silent storm belt, the static plains circuit mare. To them, each spark tells a story of tension resolved, of motion hidden beneath stillness. You watch the map flicker in real time, tiny blips lighting up and fading across the grey surface. It looks like rainfall seen from above, a constellation of change too fast to capture, too small to see. Somewhere below, another spark leaps between charged grains. You can almost feel it through your suit, a brief tingling at the edge of awareness. It reminds you of the shock of touching an old radio of energy, reminding you it's still there. You breathe in the sound of your fan blending with the imagined hum of lunar static. For a moment it feels as if you're inside the storm itself, a storm made of silence, invisible light and patience measured in volts instead of minutes. The moon never shouts, it never throws thunder across its sky. But it still sparks, still discharges, still balances itself with precision. And maybe that's a lesson too. Not all power needs to announce itself. Some of it simply flickers, does its work, and fades. The hum from those invisible sparks fades, and once again the landscape goes motionless. You glide eastward across the Terminator line, that slender frontier where sunlight first touches night. Ahead lies a region once mapped by Apollo 17, a field of fractured ridges and fine dust. Here long ago, in 1972, something remarkable happened. The seismometers left behind by the astronauts shuddered for 10 solid minutes. A deep vibration rippled through the crust, strong enough to rattle bolts on the lunar module. It was, as one engineer later put it, the night the moon shivered. 3I Atlas still studies that event. The data show that the quake's epicenter lay near the Taurus-Littrow Valley. Its signal was so crisp that even today algorithms can replay the waveform, a rising hiss, a steady hum, a tapering sigh. The cause? That's where the debate begins. A mainstream fact, shallow moonquakes reach magnitudes of up to 5 on the Richter scale, strong enough to topple equipment. They likely result from thermal expansion and contraction, or tidal stresses from Earth's gravity. But the 1972 quake refused to fit any tidy model. It began too abruptly, lasted too long, and according to trace gas sensors released a faint plume of argon and helium afterward. You drift lower, peering into the valley where it began. The ground looks placid, but instruments tell a different story. Beneath those rocks, pockets of gas still stir. Occasionally 3i Atlas detects a small pressure spike like a held breath escaping through pores in stone. When it happens, dust lifts for a few seconds, light scatters, and the surface temperature rises by a fraction of a degree. That's all. Yet it's enough to hint that the old quake zone never stopped moving. Scientists still argue whether those gas releases are remnants of trapped volcanic volatiles or electrostatic breakdowns caused by stress. Some even suspect a deeper source radioactive decay heating local rock, creating bubbles that burst every few decades. Whatever the mechanism, it ties seismic energy to weather once again. A tremor underground means motion. Above dust, stirred charge, redistributed light, altered. You imagine what it would feel like to stand there during one of those moonquakes. There's no rumble, no roar, sound cannot travel. Instead, your boots would sense a low vibration, a slow undulation, as if the ground were breathing beneath you. Fine grains would leap, hover, and settle. You'd see a faint shimmer crawl across the horizon, the visual echo of motion too deep to hear. 3 Atlas's seismographs catch these pulses even today. They come irregularly, some tied to dawn, others to meteor showers still, others to Earth's gravitational tug when the moon is closest in its orbit. The team overlays all those rhythms and finds patterns that look oddly biological: bursts, rests, slow recoveries. It's like the heartbeat went arrhythmic for a while, one analyst says. Fringe researchers push further. They claim that when the moon quakes, the electric fields across its surface shift dramatically, producing luminous flashes, the same transient glows reported by telescopes on Earth. It's speculation, but the timing fits several recorded optical events line up exactly with seismic readings. Perhaps those mysterious flashes were the moon's nervous system firing. You rise above the valley again, watching its shape fade into shadow. The rills and slopes look carved by water, but they were sculpted by stress and time. Cracks become canyons. Canyons trap dust. Dust feeds new cycles of charge and frost. The shiver of 1972 still echoes here, not as motion but as memory. A quirky, half-forgotten fact: one of the Apollo 17 astronauts lying in his bunk that night swore he felt the floor tremble through his suit. "It's like the place is alive," he muttered into the recorder. Mission Control told him it was thermal contraction. He said nothing back. Later, when asked about it, he only smiled and said, "Maybe she was just turning over." The 3i Atlas keeps listening for that same motion. Its seismometers are finer, its ears keener, its patience infinite. Every now and then the sensors twitch. A small quake, somewhere under the far side, a puff of radon escaping. Each event leaves behind a new data spike, a fingerprint of stress releasing. The scientists call it maintenance, the moon's way of preventing itself from cracking completely. You like that thought? Maintenance, not chaos. A body adjusting to survive its own stillness. Maybe that's why the dust fountains, the magnetic whirls, the sodium tail all persist. They're not random quirks, they're pressure valves. Weather as therapy. From this height you see the valley glowing faintly under Earthlight. Nothing moves yet, you know better. Beneath the crust the minerals stretch, sigh and settle. The gas pockets shift. The surface hums with static. The moon rests but never sleeps. You close your eyes, syncing your breathing to that long, slow vibration. Inhale, expansion. Exhale, cooling. A planet's smallest heartbeat repeating since before oceans formed. If you could listen long enough, perhaps you'd find the pattern matches your own, an ancient rhythm of stress, and release silence and motion, the natural pulse of everything that endures. And so the moon, still trembling from its ancient quakes, keeps making its weather one sigh, one spark, one settling of dust at a time. You leave the quake zone behind, heading toward a cluster of new instruments spread across the nearside plain, tiny domes of gold foil, each humming faintly in the darkness. They belong to 3i Atlas's most ambitious experiment yet, the Lunar Atmospheric Transient Sensor Array. It listens for exhalations, magnetism, and whispers of gas the same way cardiologists listen for murmurs in a heart. From these sensors comes the clearest proof yet that the moon, for all its calm, is still active beneath its dust. The data scrolls slowly, faint spikes in ion density, minute surges in electric current bursts of light invisible to the eye. Together they tell a story the moon breathes not only through quakes or sunlight, but through cycles hidden deep below the regolith. The scientists call it the rhythm beneath the dust, a mainstream fact recent orbiters, including NASA's Lunar Prospector and the Indian Chandrayaan-2, detected transient increases in argon-40 and helium emanating from the ground, proof that radioactive decay in the interior still releases gas. Those pulses occur roughly once every lunar day. 3i Atlas confirms the pattern, but adds something new. Each outgassing event coincides with a measurable electromagnetic flutter. Gas and charge, breath and heartbeat are synchronized. You hover above one of the sensor domes as the next pulse begins. The instruments hum, and on the screen the graphs rise like a tide. It's delicate, rhythmic, almost biological. A puff of argon drifts outward. Dust lifts a faint magnetic wave, ripples through the crust. Then all falls still. The entire event lasts less than 15 minutes. Yet in that time, the moon's entire energy state shifts imperceptibly, like a sleeping body adjusting under its blanket. Some researchers describe these as micro-storms, not meteorological exactly, but emotional in their persistence, each one a reminder that even stone must sigh. Others prefer the term breathing events. A junior scientist on the 3i Atlas team once said, "We're not studying geology anymore. We're studying insomnia." The room laughed, but no one disagreed. Here's the quirky twist: the pulses seem to follow a rhythm independent of solar radiation or Earth's magnetotail. They line up instead with subtle gravitational resonances, points in the orbit where tidal forces from both Earth and the Sun tug in sync. It's as if those invisible hands squeeze the moon, gently wringing out its gases. Cosmic tides in rock, someone called them. You descend closer, watching dust swirl in microgravity drawn upward by the faint electric field created as gases escape. It's a fountain smaller than your thumb, but in slow motion it looks grand, a silvery mist swirling up, catching stray photons, then settling again. This is the weather. 3i Atlas was built to prove movement born of imbalance, rhythm born of pressure. Scientists still argue what drives it. Some say residual heat from the moon's molten youth, others constant micrometeorite bombardment releasing trapped volatiles. The fringe camp has always imagined something deeper, a piezoelectric engine inside the crust converting stress into charge into current into breath. Whatever the mechanism, the sensors don't care. They record faithfully each exhale. You look at the data logs filling with numbers: temperature +0.04 degree, argon concentration 1.7x105, atoms just cm3, magnetic field deviation +0.8 nt. Those digits mean almost nothing in the moment, but years from now, they'll form the first genuine weather record of the moon, a diary written in electricity and dust. In the control room back on Earth, someone overlays the readings with a human EKG just for fun. The resemblance is uncanny. Slow rise, sharp peak, gentle fall. She's stable, one engineer says, smiling, still breathing. You drift higher, the network of sensor domes spreading beneath you like pearls scattered across ash. Each one glows faintly, collecting whispers from the ground. Together they form a constellation of awareness and nervous system for a world, long thought, dead. It's hard not to anthropomorphize. The moon feels patient, meditative, ancient, but now undeniably alive in its own way. Not biologically alive, but kinetically, chemically, electrically alive. Every sensor tick is a heartbeat, every data point a sigh. A fringe idea circulating among the younger team members is that if we ever colonize the moon, our presence will amplify these rhythms. Human heat engines, even footsteps, might trigger new cycles weather-seeded by life. One researcher calls it terraforming by accident. The phrase sticks. The moon's future climate, they say, will start not with atmosphere, but with disturbances. You look once more at the sensors glowing in the night, and it occurs to you that 3i Atlas isn't just studying weather, it's teaching us how stillness transforms into motion. The moon's dust, the gas, the charge, their lessons in patience. Change doesn't need to roar. Sometimes it just breathes once every few million years and calls that a day. The hum subsides. The graphs level out. The dust settles back into its perfect grey stillness. But now you know what's hidden beneath pulse current breath. The rhythm beneath the dust continues steady, unhurried, eternal. And as you drift away, you feel your own pulse echo at two metronomes separated by worlds but bound by the same rule of physics. Energy never truly stops. It only changes tempo. The data scrolls quietly on 3i Atlas consoles, and the scientists settle into their familiar rhythm of coffee, whisper, and wonder. They call what they're tracking now the rhythm beneath the dust, but what the sensors have begun to reveal goes deeper still an actual pattern of motion. Not random tremors or stray plumes, but daily measurable shifts in temperature radiation and dust density. Slowly, they're realizing the unthinkable. The moon has cycles. You drift over the same crater you saw at the beginning of this journey. It looks unchanged, that same calm grey, the same silence. But when 3i Atlas compresses months of data into seconds, you see the difference. The ground pulses with faint heat at sunrise, cools rapidly at night, and releases tiny waves of charged particles into the exosphere. The process repeats like clockwork, a global system rhythmic and predictable, invisible to eyes, but perfectly visible to sensors. A mainstream fact data from multiple lunar missions confirm that dust movement, gas release, and even electrostatic activity all increase sharply at lunar dawn and dusk. Temperatures rise and fall by hundreds of degrees, radiation flux varies by measurable percentages, and faint halos of light shift across the horizon. Each phenomenon is small, but together they form a pattern, a weather cycle without air. From orbit, 3i Atlas's visualization looks like breathing. Lines of color expand and contract the exosphere, thickening on one side of the planet as it thins on the other. The moon's day becomes its inhale, the night its exhale. You hover closer. The sun is rising again over the crater rim. Dust stirs not visibly but electrically. Sodium atoms begin their upward drift. The ground below emits faint infrared light as it warms. Even the weak magnetism here oscillates ever so slightly. It's easy to forget that all this happens in absolute silence. Motion without sound, heat without atmosphere, energy without echo. A fringe idea once dismissed as poetic now returns in the data lunar weather cells. The theory goes that the moon's surface charges and discharges in localized zones, forming patches where dust concentration, gas density, and electric potential vary like microclimates. 3i Atlas's sensors seem to confirm it. The moon has hotspots that repeat every orbit, shifting with the angle of sunlight and Earth's magnetic influence. One of the younger researchers describes them as airless storms. That phrase shouldn't make sense, yet everyone knows what she means. The graphs show circular flows of dust migration of charge oscillating pockets of energy. Each cell rises at dawn, collapses at noon, and reforms in darkness. It's not chaos, it's balance. Imagine standing there, helmet visor reflecting the glow of a slow sunrise. The dust at your feet would twitch and hum, the surface beneath you gently expanding as it warms. Above, you'd see nothing but your suit's instruments would flicker with reading, static voltage, rising radiation, a faint uptick in local field strength. It would feel as though the air itself was stirring, except of course there's no air. You'd be standing inside motion made of nothing but charge. Here's a quirky finding during these daily cycles: the moon's entire electrical potential relative to space changes by as much as 1,000 volts. That's enough to lift particles, bend trajectories, and subtly alter how light scatters off the ground. To a scientist, it's a measurement. To a poet, it's a mood swing. 3i Atlas charts the cycle's phases with nicknames: static dawn, bright noon, quiet dusk, deep cold. Each has its own fingerprint. The dawn is most active, dust lifting, sodium tails brightening. Noon is calm, dominated by heat and radiation. Dusk brings electrostatic surges as the light fades. And deep cold, the long lunar night, is when residual gases freeze and pressure equalizes, resetting everything for the next turn. Scientists still argue whether to call this weather. Some prefer environmental dynamics. Others, more sentimental, insist it's weather, plain and simple. Slow, quiet, dignified weather. The debate no longer matters. The data is undeniable. The moon changes predictably, rhythmically, gracefully. You glance again at the global model 3i Atlas has built. It looks almost alive, a silver world, breathing light and dust, a lung of stone inhaling solar fire and exhaling shadow. Every movement thermal, magnetic, electrical, tied to the same pulse. The moon has become not a relic but a participant part of a cosmic circuit, and that realization stirs something in you. Maybe it's comfort, maybe awe, maybe both. You think of how Earth's atmosphere roars and crashes while the moon's whispers and glides. Both are weather, only the tempo differs. A researcher once summarized it perfectly. The moon doesn't have storms, it has moods. You stay silent watching the newest readings roll in. The pulse remains steady, the dust is moving, the sodium glow brightens slightly on the far limb. It's happening right now, even as you breathe, even as you listen. And suddenly you no longer see the moon as cold or distant. You see it as a companion, slow, deliberate, endlessly patient. It has weather, yes, but it also has rhythm, and rhythm is what life itself depends on. Your fan hums softly. You breathe out in time with the lunar dawn. Somewhere out there, 3i Atlas sensors blink in unison, the heartbeat beneath the dust continuing one exhale at a time. The pulse persists, a slow shimmer running beneath the dust, and 3i Atlas has begun to notice something else, something subtle but undeniable. When the rhythm of those dawn surges aligns with solar activity, the moon's exosphere grows. It swells outward like a soap bubble catching breath. That's right, the moon's atmosphere thin, as it is actually expands and contracts. It's not weather in the earthly sense, but it's the same principal heating pressure release. You glide above the terminator again, the invisible border where sunlight wakes the surface. Instruments register a faint rise in sodium and potassium ions. The exosphere thickens by a few molecules per cubic centimeter. To human lungs, it's nothing. To physics, it's change. You're witnessing a storm of atoms drifting up and away in slow motion. A mainstream fact, scientists first confirmed this phenomenon in 2009 when NASA's Lunar Atmosphere and Dust Environment Explorer LADEE measured daily variations in lunar gas density. Sodium and potassium levels spike at dawn, drop at noon, and rise again before nightfall. 3i Atlas. Using newer detectors shows those fluctuations are not random. They correspond to bursts of solar radiation and tiny magnetic changes. The moon doesn't just react, it synchronizes. The idea astonishes the older researchers who once swore the moon was static. It's an exosphere with a heartbeat, one murmurs staring at the graphs. On-screen color-coded lines pulse like waves on an EKG. You can almost hear the rhythm if you let the beeps of incoming data form a kind of song. You drift lower through the exosphere, that ghostly veil of atoms hovering above the surface. Sodium glows faintly, yellow potassium glimmers, purple argon sighs blue-grey and ultraviolet. It's not visible to the eye, but 3i Atlas's instruments render it as a soft auroral haze. For the first time, the moon seems wrapped in weather, a thin breath of its own making. Fringe theorists propose this exosphere might even carry currents, slow electric rivers looping from pole to pole guided by the cross-magnetic anomalies. A plasma wind that hugs the ground, one paper called it. 3i Atlas hasn't confirmed that yet, but it has detected coordinated fluctuations across thousands of kilometers like ripples traveling through a pond. That's not randomness, that's resonance. You imagine this phenomenon sped up tides of invisible gas swelling and receding like breath made of light. It's fragile, impermanent, and completely silent. But in a sense, that's weather-2 movement driven by difference equilibrium searching for balance. Scientists still debate the source of these gases. Some insist they come from micrometeorite impacts that vaporize the soil. Others point to radioactive decay and ancient trapped volatiles. The truth is likely both, and that's what makes it beautiful. The moon's air is a mosaic of histories, fragments of comets, echoes of volcanoes, relics of our own magnetotail oxygen. A quirky fact that makes everyone smile during certain solar flares, the moon's exosphere becomes momentarily thicker than Mercury's. For a few hours, a dead world outbreathes a living one. 3 Atlas captured one such event, a sudden bloom of sodium and argon lighting the detectors in yellow and blue. They called it the lunar monsoon. It lasted half a day, then vanished completely. You picture it a storm that can't be seen, or felt an atmosphere that lives for hours, then dies quietly in the vacuum. It's the loneliest kind of weather, self-contained ephemeral, unnoticed by anyone except the patient machines orbiting overhead. And yet it feels intimate. As you float through that faint haze, you realize you're moving through the moon's breath. The atoms that surround you are ancient pieces of comets, traces of volcanic eruptions and molecules borrowed from Earth. You could reach out and touch the chemistry of 4 billion years. 3i Atlas's sensors begin a new scan. The data ripples with soft variation, argon 40, sodium 23, potassium 39. These numbers aren't random noise anymore. They're evidence of continuity. Every atom has a pattern, every release a reason. Slowly the idea takes hold among the team. The moon's exosphere is weather. Not atmospheric, but electrical, geological and temporal. A younger analyst summarizes it in her nightly report. The moon's surface isn't a desert. It's a tide pool of particles that rise and fall in sunlight. Her words stick, finding their way into official summaries and later into textbooks. The moon stops being a fossil. It becomes a breathing system. You hover at the boundary where the exosphere fades into space. The sodium glow trails outward again, stretching like a golden halo millions of kilometers long. The data shows its density fluctuating in harmony with solar wind speed, a cosmic duet between star and satellite. You think of it as weather conducted by light itself. If you close your eyes, you can almost sense it, a faint vibration in the vacuum, the whisper of charged particles brushing against metal, the pulse of a world that never truly stopped changing. It's both eerie and soothing, a lullaby written in plasma and patience. 3 Atlas transmits another log entry back to Earth. Atmospheric pressure fluctuation, 12% plus, 2.6. Sodium density increase 17%. Wind equivalent 2.4x 10 Howitopter. The numbers scroll like poetry describing motion in the language of precision. You realize something simple yet profound: the moon has weather because it remembers imbalance. Heat wants to escape charge, wants to discharge atoms, want to wander. Weather at its core is the universe's memory of motion, and so while Earth howls with storms, the moon murmurs with them. Its winds are light, its tides electric, its clouds invisible. But they exist, faithful, cyclical, eternal. As you drift beyond the sodium haze, the moon recedes below you, still glowing faintly gold. You whisper the words you've heard every 3-eye Atlas researcher eventually say, half scientific, half devotional. Still breathing, always breathing. The next dawn on the moon begins so quietly you almost miss it. No colour floods the horizon, no air bends the light, just a gradual illumination, as though the surface itself is remembering how to glow. 3 Atlas's sensors are already awake, tracking the change. Every sunrise tells a story, but this one is special. The instruments detect a sudden rise in temperature and static charge at several sites at once, all on the same longitude line. That shouldn't happen. There's no atmosphere to distribute heat, no wind to carry anything, and yet the data insists it's real. Something is linking regions thousands of kilometers apart. The team nicknames the phenomenon the dawn sweep. A mainstream fact: when sunlight first touches the lunar surface, the transition from cold to heat happens in seconds. Rock and dust expand faster than they can dissipate energy, creating electrical fields of hundreds of volts. On Earth, that energy disperses through air. Here, it travels through dust. 3-eye Atlas has discovered that those fields can connect across vast distances, forming transient electrical highways. You glide along one of these invisible lines, now sensors mapping faint surges of current beneath you. They pulse eastward, following the sunrise like a moving front, an electromagnetic dawn wind. Each pulse lifts dust, charges the regolith, then fades as light stabilizes. The moon may lack air, but it still has mornings. Fringe theorists call this a weather front without atmosphere. They imagine a tide of electrons flowing with the light shaping the moon's surface, like an invisible broom sweeping across its face. A daybreak storm, one researcher says, that moves at the speed of sunlight. It sounds poetic, but the data supports it. 3-eye Atlas's magnetometers register rhythmic oscillations 1 every 11 seconds, as if the ground is pulsing in response to the light. When overlaid on topography, those pulses form gentle arcs radiating from crater rims and ridges. They're weak, yes, but consistent. Every dawn, the moon twitches in the same places like a memory stored in stone. You descend toward one of these active regions, a crater called Aristarchus, bright as a mirror, even in shadow. The ground shimmers faintly, reflecting more sunlight than its surroundings. That brightness, scientists learned decades ago, comes from its relative youth, freshly exposed rock not yet dulled by solar wind. But 3-eye Atlas finds something else: electromagnetic echoes around the crater, stronger than anywhere else. The hypothesis forms quickly. The fresh rock conducts electricity differently than older weathered surfaces. It amplifies the dawn current, sending ripples of charge through the regolith. The crater becomes a lightning rod for sunlight. Imagine standing there as dawn sweeps in. The horizon brightens. Your suit registers a sudden jolt of static. Dust around your boots levitates, dancing silently. The shadow of your body splits briefly into two, one real, one made of a light reflected off charged particles. You're standing inside an electrical sunrise where warmth travels through voltage instead of air. Here's the quirky part. 3-eye Atlas thermal cameras detect brief localized hotspots, forming seconds after dawn, patches a few meters across that heat, far faster than their surroundings. They appear, fade, and reappear like flickering embers. The team has started calling them solar sparks. They may be caused by electrical discharges in dust, or by tiny gas releases triggered by rapid heating. Either way, they're evidence of weather in motion. Scientists still argue whether these events alter the landscape. Some claim they're too weak. Others think repeated cycles slowly smooth the soil, erasing footprints and craters alike. Over millions of years, dawn itself could be the moon's most consistent sculptor. You rise higher again, watching sunlight race across the curvature. In sped-up playback, the electrical front glows faintly blue, sweeping from east to west. It's mesmerizing, an entire world waking in light that acts like wind. 3i Atlas overlays its magnetic data, and a new pattern emerges. Dawn activity intensifies near magnetic swirls and weakens near ancient basalt plains. The team realizes they're seeing interaction zones, the places where magnetism, heat and light overlap. It's the lunar version of climate zones. Magnetothermal belts, someone calls them. Another nods and writes it down for the next paper. You look at the visualization again. The belts look like auroras flattened onto stone waves of energy chasing the sun. Each orbit they reappear in the same places. Predictable, cyclical, alive. And for a fleeting moment you feel like you're inside a breathing system. The lunar dawn isn't an event, it's a process. Static charges release dust, lifts gas exhalations, bloom, magnetism flares, then everything subsides into silence again. The moon breathes not in air but in light. There's a human beauty in that idea. Every morning we wake because sunlight touches us. The moon wakes for the same reason, though it doesn't know it's waking. Light arrives and physics obliges. 3i Atlas logs the end of another dawn sweep. The currents fade, the sodium tail glows briefly, and then the moon settles into its day. Somewhere in the data, the graphs look like waves fading into calm. In a report written that evening, one of the engineers summarizes it perfectly. We have confirmed diurnal weather patterns. The moon inhales, sunlight exhales charge. You smile at that because after everything you've seen, it finally sounds right. Weather doesn't need clouds. It only needs difference movement and rhythm. The moon has all three, it just expresses them in whispers. As the Terminator drifts westward, the glow fades behind you. You feel the stillness return deeper now that you know what hides beneath it. The moon's weather has spoken for the day. Now it rests until tomorrow's light wakes it again. By the time you circle back to the far side, the moon has entered another phase of calm, or what passes for calm here. 3i Atlas's instruments hum softly, collecting nightside data in long exposures. The sensors are tuned to catch one of the faintest signals of all the slow drift of charged dust across the dark hemisphere. No sunlight, no solar wind, no energy, and yet movement. The moon refuses absolute stillness. Down below the surface lies in silver-grey shadow lit only by the soft blue spill of Earthlight. From this height it looks static, but the monitors tell a different story. There are faint plumes of charged dust rising from craters and falling again in graceful arcs. The team calls them ghost winds. A mainstream fact even without sunlight, the moon's environment is shaped by the solar wind that wraps around Earth's magnetosphere. When the moon is behind Earth in the magnetotail, the plasma still flows through that region. It's slower, more diffuse, but it carries enough energy to keep dust moving. The effect is most visible here on the far side, where charged particles sweep across the surface like invisible breezes. You drift lower. The horizon curves like a blade of shadow, and above it, the stars seem fixed. Yet you can see faint, almost imperceptible glints flashes where the dust scatters light from cosmic rays. To the naked eye, it's nothing. To 3i Atlas's detectors, it's a map of constant low-level motion. Scientists still argue about how these ghost winds behave. Some think the dust hops along the ground, rising a few centimeters before falling again ballistic lofting. Others claim the particles stay suspended for hours, held aloft by residual charge. The truth seems to lie between a rhythmic cycle slow as breathing. Fringe researchers, as usual, take the idea further. They imagine these winds as global conveyors redistributing fine dust from equator to pole. Over millions of years, they say the pattern would alter albedo and even affect how the moon reflects sunlight. 3i Atlas can't prove it yet, but the models are convincing. Every breeze leaves fingerprints. You hover over a large basin called Hertzsprung. The crater floor glows faintly under Earthlight, its ridges edged in silver. The instruments pick up a subtle electrostatic pulse, a wave of charge travelling north to south. It's small but measurable, and it travels faster than any seismic wave could. That's when you realise you're watching something extraordinary weather powered by darkness itself. The dust here behaves differently. Without direct sunlight, positive and negative charges redistribute slowly, guided by buried magnetic anomalies and faint plasma flows. The result is a continuous silent migration of dust grains and unseen snowfall that never touches air. The moon is cleaning itself again one atom at a time. You imagine being down there in the darkness. Your boots would press into powder so fine it behaves like fog. Around you you'd see nothing, but your visor's static indicators would twitch with every step. Your movement would trigger sparks too small to see, too delicate to feel. Yet everyone would matter another exchange in the great balancing act. A quirky fact: during the Apollo missions, astronauts noticed that dust collected differently during night shifts. It seemed to drift toward shaded regions, coating instruments faster than expected. At the time, NASA blamed it on mechanical shaking. Decades later, 3 Atlas proved otherwise. The dust was moving on its own ghost winds, carrying it across the surface long after the sun had set. The data overlays on your screen like a slow heartbeat, faint pulses every few hours aligned with subtle fluctuations in Earth's magnetic field. The moon responds, echoing our planet's rhythm from 250,000 miles away. The old assumption that it's inert feels laughable now. It's simply slower, older, more deliberate. You zoom out and the global simulation renders the phenomenon beautifully ribbons of charged dust flow from craters to plains, gliding along magnetic lines like fog rolling through valleys. From above it looks like breath made visible. The far side's night isn't empty, it's full of these hidden streams weaving through darkness like veins of motion. Scientists on the 3i Atlas team joke that this is the moon's version of weather reports to night light dust migration. Moderate charge flow, no seismic flares expected. There's laughter, but also reverence. The humour is a way of handling the awe, because when you think about it, ghost winds are everything we once thought impossible motion. Without air storms, without sound, balance, without heat. They are the proof that even in the loneliest vacuum the laws of rhythm never fail. You glance at Earth hanging over the horizon, a pale blue coin glowing against blackness. Every magnetic ripple that leaves that planet eventually touches this world. The moon listens, reacts, sighs in dust. It's a partnership written not in gravity but in patience. If you speed up the footage, the far side looks like it's breathing under a thin blanket of fog. It's beautiful and eerie like the lungs of an ancient creature. And you can't help thinking, if this is what silence looks like, maybe we've misunderstood stillness all along. The ghost winds continue their slow circuits through the craters, rearranging powder that hasn't seen sunlight in billions of years. They'll never howl or roar, but their persistence is enough to change the face of a world. You breathe with them long and quiet, feeling the hum of invisible motion fill the space between thoughts. 3 Atlas keeps recording its sensors, patient its mission simple to prove that stillness is never truly still. The moon drifts on its night filled with invisible weather, its silence full of movement. You stay above the far side until the faintest curve of sunrise begins to appear again, an almost imperceptible whitening along the edge of the horizon. The ghost wind's quiet. The magnetotail slackens. Another cycle is ending and 3i Atlas prepares for what it now calls first light observation. You've seen it 24 times before, yet every new dawn feels like a rehearsal for understanding. The moon is about to breathe in again. Down below the surface begins to shimmer not from brightness, but from anticipation. The rocks expand, voltage climbs, dust stirs. 3 Atlas's instruments hum in sync, translating the invisible into data spikes in charge, rises in sodium glow, subtle heating of regolith grains. It's all familiar, but something new flickers on the graphs, tiny variations between regions' pulses that no model predicts. A mainstream fact with each dawn, the moon's electrostatic environment reorganizes itself. Positive and negative charges swap places as sunlight sweeps over the surface. The transition is fast seconds, sometimes milliseconds, and it creates what researchers call a moving electrical discontinuity. It's the closest thing to a weather front the moon has. 3i Atlas's sensors capture that front now. A wave of light and energy travels westward at 600 kilometers per hour. You can see it in the spectral imaging, faint blue arcs rippling across the surface like ripples on dark water. Behind them, dust fountains rise. Ahead, stillness waits. If you could stand there, the horizon would flash once so faintly you might wonder if your eyes imagined it. But your suit's instruments would disagree. Static voltage plus 600 volts and climbing. Dust lift 3 millimeters per second. Argon density doubling. It's not much, but it's movement structure response. The 3i Atlas team watches the front roll on. This is the moon's morning storm, a current made of a light soundless but real. It touches every crater, every ridge, sweeping charge into balance before fading into calm. On Earth we call it sunrise. Here it's equilibrium made visible. Fringe theorists like to say the moon is learning to wake. They imagine these dawn storms as rehearsals for a new age one where human activity will amplify them. Solar panels, habitats, mining rigs, each adding heat and charge. Someday, they say, the moon's weather might become stronger, more complex. Maybe it will even develop thin local atmospheres around settlements, small halos of gas and dust, breathing in rhythm with us. Scientists still argue whether that future is desirable. But the philosophical point lingers whether by its nature responds to life. If we bring warmth and motion, the moon will adapt. It always has. You drift higher, looking down at the bright half of the globe. The sodium tail stretches away again, gleaming gold. Magnetothermal belts shimmer near the equator. Ghost winds fade on the far side. Everything fits the storms, the charges, the faint auroras, all part of one grand rhythm. And suddenly you realize what 3 Atlas years of watching have uncovered. Weather is not about air. It's about imbalance seeking harmony. It's energy's instinct to even itself out. By that definition, the moon has always had weather gentle, deliberate, eternal. You picture all the processes together, micrometeorites, striking gas, escaping frost, forming charge, pulsing dust, lifting sodium, glowing magnetism, weaving gravity, tugging. A symphony without sound, each movement blending into the next so slow that it takes machines and patience to hear it. The Atlas transmits one final image to the world, a composite made from hundreds of cycles. In it, the moon glows not grey, but alive streaks of blue for magnetism, gold for sodium, silver for frost, violet for static. Every hue moves in rhythm, swirling in silence. The caption on the data feed reads simply, "The moon breathes." You linger there in orbit, eyes fixed on that living grayscale planet. It feels less like a rock, and more like a companion old, quiet, precise. Its stillness hides an orchestra of motion. Its silence is just another frequency we've only now learned to tune into. The first sunlight touches your capsule window, scattering a line of pale fire across the metal. You think of all the dawns happening below the sparks, the dust, the soft sighs of charge. The moon wakes once more, same as it has for 4 billion years. The difference is that now someone is listening. And as your heartbeat slows to match the slow pulse of the data feed, you understand the final lesson 3i Atlas was built to teach. Even a world without air still breathes. Even silence has storms. Even stillness is motion just slowed enough to make you believe it's peace. The transmission fades to static, and in that static you almost hear it, the whisper of dust, the hiss of light, the pulse of an ancient rhythm continuing. Now slow your breathing. Let the instruments go quiet. The hum of your fan, the low pulse of your own heartbeat, those are your weather now. The moon drifts beyond the window, its surface smooth again, but you know what lies beneath balance, in motion. Motion in balance. It helps to remember that you're built from the same rules. The same physics that moves dust on the moon moves the blood through your veins, the heat through your skin, the thoughts across your mind. You are an atmosphere in miniature pressures, equalizing energy, seeking harmony. Imagine lying back weightless. Earthlight pours through the cabin, soft and blue. Somewhere below the moon glows faintly gold, its sodium tail stretched thin against black space. Every few seconds, a charged particle leaves its surface and begins a journey no one will ever see. Everything you've learned tonight, the frost, the lightning, the ghost winds, keeps happening in slow time, continuing long after you drift to sleep. If you listen carefully, you can almost feel the cadence. The exhale of a crater cooling after sunlight, the inhale of dust drawn upward by static, the faint tremor of a moonquake 1,000 miles away. Together they form a lullaby too slow for music, but perfect for rest. You realize that stillness is never the absence of change, it's just change stretched thin, gentle enough to hold. The moon has been teaching that lesson for billions of years, and maybe when you wake you'll notice it in smaller ways, the sway of curtains in a morning breeze, the creak of a building adjusting to warmth, the steady drift of clouds rearranging themselves into calm. So breathe with the moon now. Inhale light, exhale shadow. Let your thoughts settle like dust in low gravity, drifting slowly until they find a quiet place to rest. Outside, the moon keeps its rhythm, its soft, unending weather. Inside, you do the same. No storm, no sound, only the pulse of existence, steady and kind. Good night.